Hello, everybody, and welcome back to Debate Hub. We are here. We are in it. We are here to win it. I am your lovely host, Chesh. As the host, I am the master debater below. I have with me, as you know, Dapper Dinosaur, the one, the only. We've also got with us the lovely Cindi Lincoln. For those of you who don't know who Cindi Lincoln is, check the link in the description. Go check out her Twitter. Go find her YouTube channel. She is fantastic, and she is lovely, and she has brought a friend with us. And I am very excited to meet our brand new friend. So everybody play nice. And it's great to see you guys. Cindi, how are you?
Hi, Josh. So good to see you. I haven't seen you in so long.
I know, it's been ages.
Yes. So now Sal has a policy that he doesn't debate his friends because he wants the friendship to be priority, not to, torture friendship. So that's going to be my priority tonight also.
Well, it's a debate, it's a discussion, it's a popcorn of ideas and, getting to know everybody and getting to know, think of it like more sitting down at a bar with some friends that you like to hang out with, and sometimes you disagree about something and sometimes you don't understand about something. So what do? You ask, and you have a conversation about
it. And my friend is Kaylin.
So there's a bit of a delay, so if there's a pause there, don't worry about it. Yeah.
Okay. Kaylin came to see me at the Science Center tour, and we became friends with that. And she's interested in the topic and wanted to join her, or I drafted her, one of the two.
Yes, I do enjoy talking about these topics. I'm very passionate about my faith and the reasons behind God and why I believe in him and things like that. So I connected with Cindi because we were both passionate about the same subjects, and so that's why I'm here.
Very cool, very cool. Dapper, do you want to introduce yourself? I mean, I'm sure everybody here knows who you are, but,
Yeah, it's unlikely that you've been subscribed to Chesh for too long without having seen me wander by. I think I was here, like a week and a half ago or something?
If not sooner.
Yeah, something like that. Yeah. And of course, Chesh is on my channel fairly frequently. I mostly do pseudo-science debunking, and there's some actual just regular old, just here's some cool science stuff. And that's most of my content. I've also done some stuff about like weird new age energy healing stuff and, things like that. And a little bit of stuff about, actually I did some weird atheist pseudo-history because a lot of atheists on the internet like to get history badly wrong. So I've talked about that a few times.
Yeah, that definitely happens.
Oh, yeah.
That was actually really what you did on Sal's?
I've done one on Sal's channel, and I've done two on my channel. One was just me going over the first council, and I see why lots of people get it wrong and how they get it wrong. And then I did another thing where I did a talk with a guy from Australia who runs a blog called History for Atheists, where atheist misconceptions primarily about Christian history from basically like the 4th century on is most of what he does. And he himself is an atheist, which is one of the interesting things about it.
Sorry. Kaylin's dad is really into Christian history. That would be a cool intercept.
Yeah.
Well, it's a fun topic. I did a lot of study in that area. So yeah, it's one of the reasons that he and I had that chat. But primarily, the channel focuses on mostly young Earth creationism because I was a young Earth creationist, and then I wasn't one. So that is sort of the reason that there's a focus there. Well, I'll tell you what. I will send you a link to the story because I've told the story twice on my channel, and I don't want to take up this discussion with it. But yeah, I have a short and a long version of that story.
Okay, I'm definitely interested.
Yeah. Is the short version like 5 minutes, and the long version is like 2.5 hours?
I think the short version is about 15, and the long version is about 2 hours. Yeah.
That was pretty cool.
Yeah, I've never heard that either, Timothy. I'd like to hear that.
Wow.
Well, so Kaylin and I are both creationists, so that's why.
I will send you that link. I'll send you the link to both of them, Cindi, and then you can forward it on to Kaylin. Does that work?
Yeah.
And for anybody else who's interested,
and for anybody else, send your click to the. I'm sorry, baby.
No, go ahead.
Send your link to about your history lecture too, because Caitlin and her dad would be interested in that.
Absolutely.
Yeah.
And for anybody who's interested in dunking on atheists, I had the Free Thought Prophet guys on, John and Seamus, and they were sitting around debunking and absolutely shredding Atheist Alliance International. So if you're interested in sort of what's gone on with that and like geopolitical nonsense and like the demolition of that current organization and their abject failure at like what's just been currently going on, go check that out. It was actually a lot of fun. I have invited the current sitting president, who was definitely legitimately elected, but I haven't heard back from him yet, so we'll have to see. So, Dapper, do you want to explain?
Send that link too.
Oh, you want that one too? Cindy's looking for all the tea and all the dirt, like what's going on. So, Dapper, you want to actually introduce the topic for tonight?
Yeah, so this whole thing grew out of a fairly long conversation that Cindi and I had, because when Cindi and I get on a phone call, if it goes under 3 hours, I consider a short call with Cindi, because you know what, we just keep talking. And so one of the things that we
5 a.m.
This is accurate. During this conversation, one of the things that came up was stratigraphy, which, for those of you who might not know, stratigraphy is the study of the various layers in the rocks of the Earth.
I'm
so
just glad
geology
he pronounced
is
because I had no idea how to pronounce it. I was like,
oh, okay.
How do you
So-
say this?
Within geology, there's a whole lot of different kinds of geology. So, like, you know, there's a geology where you study the morphology of a particular rock. You say, okay, well, what kind of crystals do we have in here and whatnot? Stratigraphy is about what layers come in what sequence, which one was first, what came after, how can we correlate them both vertically, through the layers up and down, and as well as horizontally, meaning, you know, across different locations across the surface of the Earth. And so Cindi sent me a video that she had done, and then in addition to wanting to talk about it live, I also made about an hour and 40 minutes or so worth of pre-recorded content, which is currently awaiting being published. It's not currently out yet. It's on early access on my channel. But Cindi did get the links for that because, you know, unlike most of the people I respond to, I like Cindi, so she gets early access too.
Okay, so that's not published yet, because Kay and I both watched that.
Oh, that's fine. I don't mind.
Okay.
And I'm sure that some of what we'll talk about today will be repeated on that, and some maybe will be unique to that. But so yeah, Cindi, in your video, you know, why don't you let people know what your main idea is?
Yeah.
And then we'll.
Do you want me to go ahead and state?
Yeah, sure.
Okay. So, as absolutely ridiculous as you might think it's, we do believe that there was a worldwide flood and that the rock layers do show that the world was at one time underwater, all the way up to the mountains. All the mountains, the Andes, the Rockies, the Himalayas, they all have shells on top and fossilized shells. So we do think that there is evidence the entire world was at one time underwater, and that a lot of the rock layers are deposited by water and volcanic action. Actually, I was talking to Timothy and saying that they're mostly sedimentary by water, and he said, yeah, but some of them are igneous, which means like ignite, which means fire, which means volcanic. And so I don't think those two are mutually exclusive, because if the fountains of the Great Deep are breaking open, there's going to be volcanism. So I think that, oh yeah, so one of the, in addition to the fossilized shells at the top of every single mountain on the planet, the other evidence that it was a worldwide phenomenon and not a river flood is because the extent. The layers extend over continent wide. For example, if you Google how far does the Nile River flood, okay, it's going to go just a few miles or just a short period away from the river. Whereas if you look at the deposits on the Earth, they cover continents, not just little bands of river. Rivers pale in comparison to the extent of the sedimentary deposits. I think that's all. Go ahead, crucify me, Timmy.
No, I don't think that's gonna be necessary.
No,
you don't.
So
no.
There are a few things that I want to talk about. One is that it is the case that if you look synchronically at a river, so at a single point in time, a single river is going to be a fairly narrow channel, and even when it floods, that floodplain is going to be relatively narrow. However, just you brought up the Nile, and just with the Nile, we know from just historical records from the Egyptians themselves that over the course of Egyptian history, the Nile has migrated all over what's now called the Nile Valley. And that's because over time, rivers do migrate, and we can watch it happen now. In fact, the United States government is spending absurd amounts of money just to keep the Mississippi flowing through New Orleans because it's wanting to change course. And so they're pouring huge amounts of man-hour and money into building up earthworks to try to keep it flowing through New Orleans so that way they still have that river trade. And so it's not the case that rivers only deposit in a narrow area. Plus, you have things like river networks, like the Amazon or the Orinoco Basin, two of the biggest drainage basins, as well as the Mississippi. Those together are the three biggest drainage areas. All those tributaries also meander. So if you were to extend that through time, your expectation would be that you would be getting fluvial deposits from that entire valley area, not just the narrow band of the river. There are exceptions to that, though, like the Colorado River is not likely to migrate very much anytime soon because, it's at the bottom of a deep canyon. So that's one thing with the fluvial thing. Another thing is that it's less important about the igneous rocks, and what's more important are the sedimentary rocks that are not well explained by water. So, for instance, sand dunes form both underwater and in the air, but airborne sand dunes have different characteristic angles for the dunes, and we can see these differences in dune crest shape and angles in the crossbedding of sandstones. So, for instance, we can tell the difference between a subaerial sandstone, which is one that's formed under the air, and a submarine, which is one that's formed under the ocean. And so we can actually measure this. And so, for instance, one of the first formations that you brought up, Cindi, in your video, which I know people here probably haven't seen, was in the Navajo sandstone. And the thing is, the Navajo sandstone, in fact, has the cross-bedding characteristic of desert wind-borne sand. There's also things like we have subaerial tuff, which is what happens when ash falls from a volcano under just the air. It's not hitting the water. It's just falling on top of land and then compacting. Famously, there's ashfall beds in the United States, which is a gigantic fossil graveyard full of mostly things like odd-toed ungulates. These are animals like horses and rhinos that don't exist in North America anymore, but since they were caught in this volcano, presumably they did then. And so there's dozens of them all under this ash. But the thing is that ash forming underwater has different or ash rocks that form underwater are going to be different than those that form under the air. So we have those things there. Also, even when it comes to rocks that do form underwater, there are characteristic types of rocks that form in high energy events like floods or flood runoffs or tsunamis or even just rapid flowing water versus rocks that form in low energy environments like
and if you want to learn everything you could possibly want to learn about volcanoes, go check out the other Debate Hub episode with Landon Kirknowell and Manya, where we talked about current volcano activity, old volcano activity, and just general need-to-know knowledge about volcano and like a good splash of Hawaiian culture. So if you're interested in that, I also think that there's
It was very interesting.
There's going to be
really
another
Put the link. Put the link, Chesh.
More links. Subscribe to my channel, damn it.
I just recently heard that each volcano eruption has a signature. So when you look at a rock and somehow under a microscope or whatever kind of equipment they have, you can identify that rock with which eruption. That is double.
Yeah. So
when?
So what happens is the magma chamber that is going to be forming the eruptive elements like the lava or the ash or whatever, that's going to be formed of characteristic rocks that have their own particular chemistry as well as their own particular isotopic ratios. So when there's an eruption, the same volcano is going to have about the ejecta from each volcano is going to be unique in that it's going to have that volcano's particular chemical and isotopic makeup, which means that you can do things like say, okay, so this ash bed formed from one volcano and this one formed from another. And even if you can't necessarily identify where that volcano was, you can still tell if it's one volcano or two volcanoes, or whether it's one volcano then another than the first one, which itself is actually one of the reasons that we assign a minimum age to certain strata. Because one of the things I want to point out is that people aren't dating the age of the Earth just on the basis of looking at strata and counting them up and assuming a certain deposition time and a certain lithification time. Those are what give us a minimum. So if we say, well, this has all the characteristics of a low energy shallow marine water deposition. It has tidal cross bedding, and it has what looks like seasonal variations in the various laminae within the stratum. Then you can say, okay, well, here's how fast a rock with those characteristics from our experiments can deposit, and this is how thick it is. So that's the minimum amount of time it would take to form this. And then if you do that through the entire stratum, you get a minimum age for how long those rocks took to form. But what that doesn't give you is an age of the Earth. For that, we primarily rely on radiometric dating, which is not really what we're here to talk about. So if you want to reject it, I mean, I'm not really going to argue against you doing that.
Are you guys still talking about the layers on the picture that you showed me, Miss Cindi? Those rocks, or is it something completely different?
Which picture?
There was like the layers, the lines that were like really straight. I think we were talking about that. I don't know. I wish there were images.
She's talking about the one with that will have the layers that dates rocks all the way down. They're generally color coded.
Yeah, that one.
Yes, he's talking. Sorry, go ahead.
Chesh. Sorry, babe. Go ahead.
I was just saying that what Dapper's talking about is that those are basically that chart would apply to how you would either recognize or that we can use information gathered from volcanoes to decide where within that strata that rock may come from.
Yeah. Mm-hmm. So
you're saying
I guess my sort of like 20,000 foot view of this is basically
wait.
We know.
Oh, sorry.
Okay.
I wanted to.
Sorry, there's a lag.
Kaylin's.
There's a delay. Yeah. I'll just shut up.
Thank you. I wanted to follow Kaylin's path a little bit. So you were talking about really narrow lines, right? Instead of the larger geologic column definition. Yeah. Now, when Timmy was first talking, he was talking about the Navajo sandstones, and I Googled it. And that's the first image on my video where they used to be horizontal and really fine little lines instead of large, and it was all curled.
Oh, there's a lag. You said it was curled?
It was all, if you have an open tab, just Google Navajo sandstone image. They're gorgeous. So Timmy was trying to say that each of those layers, if they're curled, Timmy, if they're curled, they'd be soft at the same time, and they all had to be moved at the same time. So if you've got this many layers and they're all in a swirl, that means this many layers had to be soft at the same time. Because if you look at the beautiful curve, if the top were soft and the bottom were old and hard, they wouldn't be like one fluid medium. They would be like, this would be more fluid and this would be more cracked. So I think that's a substantial argument.
And then I heard him mention something about sand. I think also in his rebuttal he said something about that, like the wind or something like that, right?
Yes. How some, okay, if you look at the sand that's at the bottom of a lake, for example, it'll have certain patterns of current,
Right.
how the current makes the sand go up and down. Whereas Timmy was saying, if it's not underwater, if it's under air, it'll have a different pattern, and that they can therefore identify which sands, which later turned to rock, which sands were put down by water and which sands were put down by air, is what he was saying. And then after, in order for a rock, it's got to be, it's got to have a cementing agent act upon it. So just sand by itself, it ain't going to turn into a rock. It has to be buried by, and so that a cementing agent can permeate the whole thing. Silicates, calcium carbonate, the things you make concrete out of, that's how you turn a sand to a rock. Right?
Go ahead. I think Timothy wanted to say something.
Yeah, so there's something I want to talk about with the folding in Navajo sandstone, which is most dramatic at a formation called the Wave, which is around it's just on the Arizona side of the Arizona Utah border. And so it is actually the case that the conventional explanation for this formation is that this was bent before lithification occurred. And one of the reasons that's the case is because.
Yeah, say it again.
Sorry?
I didn't hear it.
Oh, so.
I'm sorry.
The reason.
Say it again.
No worries. The wave in the Navajo sandstone, which is right around just on the Arizona side of like the Arizona-Utah border. The reason for that is in fact that it was unlithified, so there wasn't rock when it bent. And one of the reasons that we can tell that is because it is so smooth and because there are so few fractures. But what it doesn't explain are the rocks that match the results of experiments with plastic deformation of already lithified rocks. Because the thing is, we have deformation experiments in rocks going all the way back to 1910. So we have 112 years of experience knowing how rocks that are already hard can bend, and they do form fractures, but what they don't do is simply snap, and that's it. We have experiments where we can actually, in the lab, show that under sufficient temperature and pressure, rocks do in fact bend. This isn't a supposition. This is just, it's as much an experiment as,
explored.
Okay.
That's something I have not explored at all. But I did want to ask you, at first you said that the explanation for the wave in Arizona is that they were not lithified. Okay, they were
Correct.
not yet
rock. It was still
sand. Okay, let's picture some sand. Okay, pretend you're at the beach and you've got sand, and it's okay. You know it was straight because it's layered. Okay, now picture it turning into a wave. Okay, sand is going to fall if it's not lithified, if it's not a rock.
Well, so the thing there is that
if it's okay, let's use my finger. Okay, so because you're going to have layers like that are equidistant apart, and if layers and they remain equidistant even though they're bent, okay, as opposed to sand, the layers are going to fall out if they're sand and they're not congealed in some way or lithified.
So there's a few things there. One of the more obvious things about the wave, if you look away from the actual wave itself, which is hard to do, I'll admit, because it's a very striking formation, there's actually an angular unconformity above it, meaning that before this all was formed, right, there was additional rock on top of what's now the wave that has since eroded, because that's how you get, there's no other way to get an angular unconformity like that. And so the way that you can get, and this is true for rocks in general, the only way to get rocks, whether they be currently lithified or still being sediments, to fold while maintaining this lamination that you're seeing in the wave, is if there's confining pressure, which means the top and the bottom both have something there to keep it in place. So this wasn't on a cliff or exposed to the air when it bent. There was something on top of it, and various things like tectonic forces and the confining pressure allowed it to bend without too much mixing of the laminations. And this is going to have to be the case under any model of bending, because without that confining pressure...
What does the angular unconformity have to do with the... Okay, so what he's saying is the wave is all these layers in a bend, like a wave. They are underneath an angular unconformity, where instead of them going all the way up, they are cut off. They're seared.
They are.
Brand layering going on top of them, bent. Okay, so you have a bend, and then on top of it, you have a new deposit that is bent. Okay, so you got the bended layers and you got the flat layers. So what you're trying to say is that these flat layers on top of the bended layers press together so that the sand couldn't fall out.
Well, so
but where did that
before that
come from?
So because there's an angular conformity, we know that there's rock that was there at some point, or at least sediment that was there at some point that isn't there now. Because in order to get an angular unconformity, that overburden has to first be eroded, and then new deposition has to come in to form the rocks on top of the angular unconformity. But what I'm saying is that missing rock that has since been eroded away, meaning it was probably fairly soft, especially since, sandstone isn't the hardest thing in the world, so it was probably very, very soft. But it was also going to be heavy, and this is a thing where this is not actually a difference between any young Earth creation model versus the scientific model. In both cases, in order to get bending like this, whether the sediments are hardened or whether they're liquid or whether they're already just dry sand, you're going to need confining pressure in order to keep the layers relatively coherent, as well as to keep them from simply collapsing in on themselves. So we don't really have to explain on either idea why the laminae stay where they are. And in fact, I would say that just the bare layering and the fact that there are laminae and just the fact that there is the bending in this particular formation is actually reasonably consistent with some kind of flood model where there's been lots of tectonic activity. But what isn't is the angles of the cross bending, as well as the fact that these laminae are identifiably seasonal, where they have things like different wind directions, because again, we know this is wind because of the angles of the cross bending, which are consistent with wind-borne sand dunes. And we also know that the laminae are in fact seasonal. The Navajo sandstone. So the Navajo sandstone is characterized by two big things in addition to this bending, which is not as extensive everywhere because it's a relatively big formation. So one of the big things about the Navajo sandstone is it's characterized by seasonal laminae, and we know that they're seasonal for a few reasons. One is the direction of the wind changes, and the other one is because we have relatively rapid changes in the composition of the sediments forming the rock, which it's hard to explain without some kind of change in direction of flow. And when that happens with wind, in this type of area, it typically is associated with a change in season, going from summer to winter, things like that. So everything about it that isn't well explained by both models is only well explained by aerial deposition with seasonal wet seasons that then allow cementing agents to cement the rock together lower down, because the higher up layers are going to stay unlithified because the water is going to evaporate quickly. But the water that seeps down into it can dissolve cementing agents, allowing that rock at the bottom to lithify. And so the problem is that, and it's actually a problem that I noticed through the whole video that you made, which I think maybe, Chesh, we should link to that after this. We should have that as a link in your description after this is Cindy's original video.
Yep, I will definitely add that. I'll probably actually also pin it in the live chat momentarily as I pull it up.
Okay.
And Timmy,
one of the problems... Sorry.
Jump to another subject? Because before you jump to another subject, I want to weigh in with Kay and see what she's feeling.
Yeah, I'm telling you guys, it'd be easier if there was pictures, because a lot more things make sense with pictures, but I'm trying to just make sure I understand exactly what's being said. I was telling Cindy, I'm not sure because I don't really know that many scientific terms, but basically, when I watched your rebuttal, pretty much from what Cindy was explaining to me, I was just trying to figure out why, you were giving explanations on other possibilities, right? But it just seemed as though like, why would those things happen? Like the flood kind of gives it more of a logical explanation of why those things look the way they do. I'm not even talking about just like it makes sense, but like it actually, like with the straight lines and everything, like it just kind of seems like the evidence that she was explaining for those things, it makes more sense than random, things happening just because they're possible.
I think I can explain that. So
real
one of
quick
the things
before
is that
you jump in, sorry, what's the name of the video I'm looking for?
Cindi, do you remember it? You know what? While I'm going, I will look for it and I will send it to you, Chesh, on Discord. Does that work?
Yep, that's perfect for me. Also, Cindi, you were interviewed by Brett Keane. I had no idea this happened, and it blew my mind.
Wait, twice. That's why I was about the dumpster fire, Chesh. A very, very
my entire world just imploded. Sorry, please, Dapper,
would you
go
agree
on.
or no?
So
it would be
the reason that geologists usually propose things like this is a few things. One is if we have, so one of the things is geology isn't just an observational thing. There are experiments, right? So there are what's called sedimentation experiments, where you set up an experiment to show, okay, I think, first you step out and you say, okay, I see rocks forming today, as well as rocks that look like what those rocks should be. And so what I want to do is test what different kinds of environments could produce this. And also, we have things like, we know that certain things happen, like when seasons change.
Before you continue, okay, you want to explore certain situations where these rocks could form based on what we see today. And that's kind of what Kay was saying. She was saying, basically, if I could add a phrase after that, you're trying to find environments where those rocks could form other than in a worldwide flood.
Well, no, that's actually not true, because one of the things that is tested in sedimentation experiments is flooding. So, for instance, it's not the case that no rocks are explained by floods. There are many rocks that are in fact well explained by floods, as well as many whole landforms that are well explained by very large floods. And it's not that geologists are saying, well, we can't be a flood. In many cases, they're saying, well, this was a flood. But in other cases, they're saying, we don't have an experiment or any observations that can support a flood for this particular rock. And so I would say that what is incumbent upon flood geologists is to actually go do the sedimentation experiments. Get the sediment, get the cementing agent that you want, put them into a situation where you're mimicking a turbulent flood. And of course, you can scale it down. You don't need to flood the entire world. Please don't. But, show how a high-energy environment could produce fine-grained, non-flocculated shale. Show how a high-energy environment could produce sandstone with cross-bedding characteristic of wind deposition. Show how
say stuff like "Don't flood the earth" because he knows I'd do it.
Yeah, you would.
How could you do that?
Oh, she would find a way.
How could you literally flood the earth?
It's only a matter of time.
Chesh's secretly a supervillain. It's actually not that big of a secret.
You guys think it's possible for one of you guys to flood the earth? Like literally. If you desire to flood the earth.
I am currently under the impression that to become a god, people just have to believe in you hard enough. So if
you must have been watching a lot of American Gods.
I play too much D&D. And so basically that means if enough people believe in me and enough people hit that subscribe button and start sending me their power, I will become a god.
Eventually.
She's going to be a vortex collecting all the power and focusing it.
All right, sorry, Dapper, please continue.
So, yeah, that's one of the things is that there have been sedimentation experiments, as well as people just observing what happens after a flood. So the thing is, flood rock is actually pretty characteristic. It's reasonably easy to identify. For one thing, it tends to primarily be composed of coarse grains up until the very top of a given flood layer. And that's simply because of hydrodynamics. Hydrodynamic sorting is a real thing, and bigger and denser things fall through a water column more quickly. And in a very turbulent event, very light things will stay suspended simply because gravity is going to be weaker than the action of the water acting on those particles. So on net, they tend not to fall at any significant rate. And so you tend to get things like graded. Oh, sorry.
Okay, remember when I was showing you the jar that I shook up and how certain things fall, certain things fall second, and certain. So that's what he's talking about, the grading. But if you've got flow move around and it's not necessarily turbulent, you might different kinds of sedimentation than rapid flow.
Well, so one of the things with
the inland sea, with your model of the inland sea, like how long would that be there? And wouldn't it? It's not necessarily turbulent at all times. A worldwide global flood would be turbulent and not turbulent. It says the waters came in and then the waters rushed off, and it took 150 days to rush off.
So the thing is, in order to add that much water to the world in the space of the amount of time that the Bible describes for just the rising of the water and how deep it describes it as being, there really isn't an option that would count as low energy. Because when geologists are saying low energy deposition, they're talking about things like tidal estuaries and slow moving broad rivers and gentle winds over, or even in some cases relatively heavy winds, but still wind over a desert. They're not talking about fountains of the great deep and rain for 40 days of rising water. That would be high energy in a way that is there is no way that any geologist would describe that as a low energy event. And the thing is that, generally speaking, it would also have an ordering effect, right? We would need to see. So let's say that the flood is tranquil until it's
for 150 days, Timmy. It's not going to be a homogeneous event.
I didn't say it was going to be homogeneous, but it's going to be what would constitute high energy.
It would be high energy, especially when the breaking fountains of the Great Deep are breaking up. But that doesn't mean it's going to be like that the whole time.
Well, so one of the things, though, is that the tranquil portions are not going to be the primary sedimentation periods. In fact, if you look at people who are doing flood geology now, if you look at their models for when deposition is occurring, it's primarily occurring in two phases. It's occurring during, and this isn't just me saying this, right? This is me reporting the young Earth geologists saying this. They're saying that a majority of the sediment that is deposited during the rising phase of the waters. Then there is a portion where the waters are staying roughly at the same level. Chesh, I did send you that link on Discord. And then there's going to be...
You sent me an image, and I am...
Oh, did I? I might have sent the wrong one.
I'm going to show the image because this is the sand dunes everybody's been talking about. So I will show it so that way you guys can see.
The copy button seems to be not working. I think, is my keyboard broken? Copy.
Oh, no.
Right?
But Timmy, what you were saying prior to that time is that sedimentation only occurs when it's a low energy, because if it's high, the sediments are going to stay floating.
No, that is not what I was saying.
To allow the stuff to down.
Yeah, that's not what I was saying. I was saying that there's a difference in which sediments. So sediment is just any hunk of rock that a cementing agent forms around. So, for instance, in sedimentary rocks are normally named after the sediment. So siltstone is made of little particles of silt that are cemented together. Sandstone is made out of bits of sand. Okay. So in a typical flood deposit, what will happen is that the biggest sediments will flow down first because they are the ones for whom gravity is the strongest force compared to the water. Because it's always a balance of forces, right? If the water is stronger than gravity, then you're unlikely to settle out. But as the flood goes, it tends to become, the amount of energy in the flood tends to go down. And so what happens is, first the biggest, heaviest rocks sink first, then you get things like sand, then you can get things like silt, and things are going to ultimately form things like shale, going in finer and finer grading. And in fact, actually, one of the things I liked was even in your nut milk example, where you blended up some nuts and then put them in some water. One of the things that formed is you can visibly see the larger hunks of nut towards the bottom, the smallest solid pieces of nut towards the top, and then what's still in the water column is the really fine stuff, the really, really like microscopic particles. And if you were to let that dry out, what you would get is a single layer that goes from really thick chunks at the bottom, and then slowly goes up to the smallest. And that's the kind of thing that you get in a high energy event like a flood. And most flood geologists have a model where they have significant deposition for the rising stage, very little, if any, for any stage where the water is at about equal level for that period. And then they have subsequent erosion and infilling of any then existing low areas during the waning phase of the flood, followed by a very short period of post-flood geology that is more or less, consistent with processes we see happening today. And so what I'm saying is that, right. So what I'm saying is that many of the rocks that we see right now in areas that flood geologists count as either rising or falling floodwaters are inconsistent with that. So we have things like fine-grained shale that doesn't have flocculites in it. And a flocculite is you know how when there's a cloud, it doesn't tend to rain unless there's some kind of little particles like dust for the raindrops to start condensing around. And then they start to build up a bigger and bigger raindrop as it goes. But it has to start with that little nucleus of some kind of little dust or something. That's why people have experimented with cloud seeding by just spraying fine dust onto a cloud to get it to rain. Well, flocculites are kind of like that. You get a little particle of something that the shale particles can stick to. And then as they glom onto that, then they start to become heavy enough together that gravity becomes a stronger force. And so when you have flocculites in shale, then you can say, well, this was probably deposited relatively quickly. But we have most shale doesn't have any of those. And we know how fast shale particles can settle out in water, and it's not very fast. And also, one of the big things about a flood model is that for first the rising phase and then second the waning phase, the sediment should more or less for that entire phase be ordered by density, but they're not. We have many areas where we have high density, then low density, then high density, then even higher density, then low again. In essentially what,
well, that
if you just look at
trying to say
column, it's
that we're looking at, if those wave lighters were at one time horizontal, how deep would they go? Looks like they're going to go maybe a 3-story building or something.
You mean like if it was up and down, horizontal rather than vertical?
In its original place.
Well, when you say horizontal, what kind of, because I think what happens here, sorry, I'm jumping in a little bit. I know I'm not really supposed to be too much part of this, but I'm jumping in to try and maybe help a little. When you're talking about whether or not something is up and down, there tends to be something that happens when you're talking about the scale of something. The scale of the Earth is massive. Like, massive. So up and down and left and right and north and south and vertical and horizontal, what seems very vertical to us, while we're looking at it, might not be as vertical or horizontal as it may seem, right?
Well, if you look at these layers that are curved, do you think they were laid down in a curve, or they were at one time like this and then something curved them?
So I think a better question to ask would be, not to say your question's wrong, I would just say a different way to phrase the question would be, hey, Dapper, how does science say this was formed?
Oh, well, so first we would say that there is a desert with, dune environment. And this desert has some strong seasonal characteristics. So it was what's called a monsoonal desert, which is the kind of desert I actually live in. Although I live in a rockier desert than this would have been. So a monsoonal desert is one that overall gets very little rainfall. But what rainfall there is concentrated in relatively heavy storms over a relatively short period of time each year. So, for instance, here in Arizona, almost all of the rain that we get every year falls over the span of like a month or so. And it's usually when it's raining really hard. It doesn't sprinkle here, right? There's like a downpour for a few hours, and then it just buggers off. We get dry weather again. And so the reason that we say this is, one, we have cross-bedding in the sandstone that is characteristic of wind-borne sand, but we also have things like lithification and these folding events that look like they happened under the surface as a result of there being water underneath. And the reason that water can be there while also having wind-borne sand, because wet sand doesn't get blown by the wind very well. Only dry sand does. And so that right there was wet, and then there was tectonic pressures as well as other pressures on top that allowed it to deform very smoothly before it lithified. And another reason that also we say that this is desert-borne sand is that when you have wind-blown sand, it tends to get what's called dusted. This is sort of like if you take like glass, right, and you scuff it up, you get that frosting look, right? So these sand grains are frosted. And that tends to be very characteristic of dry desert environments. It is not impossible in marine sediments. Usually it does mean that some desert sand has washed into the water. But because of the very, very well frosted appearance of the grains, the characteristic cross-bedding of wind-borne sand dunes, as well as the fact that we have very significant changes in the composition of the sediments as a result of changes in wind direction, all of that adds up together to say this was a seasonal desert with monsoons similar to ones that we can see today, and we don't know of any flood environments that can physically produce this. And so while I'm not saying that it's impossible to form under a flood environment, what I am saying is that there are a whole lot of people whose job it is to convince me that it was formed under a flood, and they have not ever done an experiment to show that it physically could happen. And that concerns me.
Okay. Go ahead, Kay.
So another experiment would have to, like, somebody would have to show you that a flood can form that, basically?
Yeah, because we know that a non-flood environment can form it. We have a physical mechanism for this to form in a sandy, monsoonal, seasonal desert. What we don't have is any known flood mechanism.
And Dapper, what would that kind of an experiment entail?
Well, so you'd want to do, there's a few things you'd want to do. First, you would want to get the different kinds of sediment that are here. So you see how there's, in the picture we have, there are the dark reddish laminae, as well as the light kind of beige to white laminae. So you would want both kinds of those sediments, and then you would also want whatever the cementing agent is. I don't actually happen to know off the top of my head what it is in the Navajo sandstone, but you would want to get all of that and a whole bunch of water, and you would want to try every way you can think of to get a high energy water environment of whatever size is going to work for you to make at least the horizontal version of the sandstone. Because like I said, the folding, I think both models do a good enough job at. I don't think the folding is really the concern. Is conventional science does not say that these were solid rock when they folded. It says that about other folded strata, but not these. So I don't really care if you can reproduce the folding. Even if you can't, that's fine. All I would want to see is an experiment where you use high energy water environment to produce these laminae in distinct bands like this, with the cross-bedding associated with windborne, that we at least associate with windborne sand. And that's it. If you can do that, then I'll say, yeah, you have a reasonable case that this was actually formed in a flood.
Right.
But so far...
And in a nutshell, I'm sorry, go ahead, Cindi. I was just going to...
First of all, any cross-bedding, it looks like very linear, any of this. And second of all, what is the extent? How much territory does this cover? Because when you have sand environment and it's blowing wind, the wind is blowing sand around, you've got dunes and you've got, you don't have the exact homogeneous stripes like that. You have, the wind is going to dune things up. That looks like you're the jar with the water in it. Go ahead.
Can you just explain to me in a nutshell his explanation? Like, a short explanation of why that looks like that.
You're saying it's airborne, or that it could be
Just air?
airborne?
Like air?
Like it would be a desert environment instead of the bottom of water. Is that right, Timmy?
Oh, sorry, I was muted. Yes, yeah. One thing I want to point out, though, about cross-bedding is that it is not always the thing that is very easy to see on just a photograph. And also, much of the cross-bedding is, in fact, more obvious in areas with less folding. So there are those two things. So the cross-bedding that occurs in other parts of the Navajo sandstone that are less folded is more obvious in just pictures. But also, this is actually one of the problems that I had with your video, Cindi, is that you showed a lot of really cool pictures of a lot of stratified areas with some really cool formations, and there was a lot of, I had to look up a lot of stuff to know what I was looking at. But that's the key. A photo, especially after YouTube compression and all that craziness, is not going to be sufficient to know what something actually is. And so one of the things I would encourage anyone out here, but especially the young Earth creationists, is before you decide that you want to talk about a particular rock column, check to see what it is. What is at least the conventional explanation? Because the thing is that the flood model has to do at least as good a job as conventional geology before it can be considered. And so I would say that, to put it mildly, there's a very, very large amount of work left to do in terms of experimental geology by flood geologists before they can even begin to have a model where a flood can cause most of the rocks that we have. Most of the rocks that we have at this point, science has come to the conclusion that it is physically impossible for them to be the result of a flood at all, never mind a single worldwide flood that caused all of them. And this is actually an example. Current scientific understanding is that this physically cannot be a flood rock at all. And so
Why?
Maybe it is, but if it is, we need to have a new mechanism. We don't.
And so why is that not possible, Dapper? I'm pretty sure you had touched on that, but if you want to kind of specify,
there's a few things.
Focus on that.
One is, like we talked about, the different laminae. So I'll do a little bit of a term here. A stratum is a single layer of rock that represents a broadly defined depositional environment. So for instance, this Navajo sandstone is a stratum, and within it are laminae. Laminae are the layers that you find inside of a stratum, and they represent some kind of change within that environment that usually had some kind of periodicity. As you can see here, where there are alternating bands of dark and light laminae. So that has some kind of periodicity. Right. So
What'd you say, Cindi?
one of the
So laminae are like the stripes you're looking at, and
okay.
stratum is like the entire thing, which looks quasi-homogeneous. So you're considering it one strata.
Right, but one stratum. So strata are usually relatively broadly defined. So we'll say like, okay, this is the Navajo sandstone because throughout its entire vertical extent, it's basically the same kind of sandstone, even if it does change a little bit from top to bottom. And then above and below it, we have significantly different kinds of rock. So we'll call those other different strata than this one. And within a stratum, you can get what are called laminae, which is the striping that you're seeing. So these layers are not themselves strata. They're laminae within the stratum of the Navajo sandstone. And the reason that the reason that science currently concludes that this physically cannot be the result of a flood is a few things. One is there's no evidence of grading in the beds. So, excuse me 1 second. Sorry about that. So, in a flood, we characteristically, just like in Cindy's nut milk jar, we have this grading where the larger sediments go toward the bottom, and then they transition to smaller, lighter sediments on top. But here we obviously have a repetition thing where it's one after the other in very neat, orderly ways. Another thing is that we have characteristics of wind-borne sand, like the frosting of the grains, as well as, while it's less obvious here, it is more obvious in other parts of the Navajo sandstone, as well as cross-bedding. We also have two very distinct types of sediment between the laminae. So we have this distinct reddish-brown sediment and this distinct whitish one. And for that to be the only two coming in there, it's not impossible for a flood, but it's very uncharacteristic because floods tend to be ripping up rocks from their entire course. And unless their course happens to only contain exactly two kinds of rock to erode and then deposit, you're going to get significantly higher diversity of sediment types, which is typical of actual flood deposits that we're seeing in forming now,
Timmy,
as well as
that's the unconformity he was talking about, Chesh. See how it's horizontal instead of folded. But what you did just concede something, and that is this whole stratum laid down essentially at one time, even though it's laminated.
During one, that's not what a stratum is. It's a single depositional environment. It is not a simultaneous event. So a depositional environment means that the reason and the method of deposition is relatively the same for the entire the entire stratum, but that does not imply that it all happened at one time. It, in fact, usually cannot all happen at one time because otherwise we would not get lamination. And also some strata have minimum deposition times on the basis of their physical and chemical characteristics, which means that we know they have to happen.
You said if it was all at one time, you would not get lamination.
Right. If a whole bunch of sediment in a single event were dumped, you would not normally get lamination. Something unusual would have to happen for there to be repeated lamination in a single event.
Well, let me ask, where's stuff coming from? So what you're saying is only this much comes at a time, and then a later time another comes, and then another. But it doesn't look laid to different.
If it's by wind, I'm sorry, I'm just trying to understand. If it's by wind, then that means that, wouldn't that mean that there would have to be a certain force of wind that would make that one layer and then another one? Is that how it works?
So yes. So I'll try to answer both questions at the same. I'll try to answer both questions. So the reason that the mainstream explanation for why there are different distinct types of sediment is that the sediment is all coming from some rocks that are already lithified elsewhere. And I believe the Navajo sandstone is feldspathic, if I remember correctly, but it might not be. In that case, it does mean that it's... Yes, that means it comes from feldspar. So there are some feldspar rocks somewhere away from this desert that are being eroded primarily by wind, because basically things like bits of quartz and whatnot are being carried in the wind. That's always the case. And they're striking into this feldspar and breaking tiny little bits of it off, just little grains of sand. And the reason that there is these two very distinct types of sediment in this is because we know that during season changes, the direction of the prevailing wind can change. And that happens just today on Earth, right? So it'll be like during one season, the wind will be coming in from the west, and another season will be coming in from the east. And so we have rocks in different directions from this desert that have a different composition, which leads to two distinct grain types forming the Navajo sandstone. And the reason that it's laminated is because during the summer, one group of rocks are being eroded and carried in. And then during the winter, another group of rocks are being eroded and carried in. And that's why we get a sequence of dark light, dark light, dark light going up through the sandstone. And so in a single flood event... Oh, okay, go ahead.
Objection.
You said you object. I didn't get my answer.
If you have a waved surface and you have wind blowing in new stuff every year, okay, the wind isn't going to lay it down with a same stripe. It's going to fill the dips and be higher and lower. And those are just too perfect.
Based on what, though? It's going to be higher and lower, based on, in what scale are you talking about?
I think any scale. Anytime you have a layer, and then another time is going to bring in another layer by wind, it's going to... But why is it so perfectly...
Wouldn't the first layer have filled anything in?
Assuming it stays straight.
Well, okay, so let's say you've got flat rock, right? You've got a flat rock, and you've got some divots, and you've got some, like, maybe looser, like, kind of, you got, like, a little bit like a basketball. The first wave is going to fill everything in. So the first season is going to fill all that in. If you've got, like, let's say it's deep enough. No layer above that is going to fill, there's no more divots to fill in after the first layer in that case. And especially after it gets pressed down and then it needs a straight surface.
How long is a layer going to sit around and stay straight? Because normally, depending on when this other new layer comes, if there's any time, there's going to be rain, there's going to be footprint, there's going to be roots, there's going to be erosion where there will be more divots.
In a desert?
So can I jump in for a second?
Yeah, go for it.
Just
so there
understand
are
how everything is straight for a very long time.
There are a few things. One is that the Navajo sandstone is actually not composed of primarily horizontal laminae. Now, because we're looking at the wave, it's very hard to tell exactly the direction of deposition because, sorry, on its own, this particular folded bit of strata, it's hard to find the direction of younging, which is the direction that the thing was deposited in, is what that means. But if you look at areas that are not very well folded, the Navajo sandstone still has these light dark laminae, but in fact, it is primarily made up of various angled crossbeds, which are actually similar to, if you look at the top of that unconformity, Chesh, you go to the left there, you can see that it's actually less folded there. That's typically how the in situ Navajo sandstone is going to look. It's going to actually have fairly obvious diagonal layering, and that is because the sand dunes are being preserved in that. But also, one of the things is that most places with sand dunes aren't the Sahara, where we get these mountain-sized sand dunes. Sand dune deposition typically doesn't involve sand dunes that are that high. In fact, one little anecdote is I remember there being sand dunes on the aircraft carrier I served on when we were in the Persian Gulf because sand was blowing into the ship, and it would pile up, and you get these little rippling sand dunes right across the deck that we had to sweep up every day because you can't have a whole bunch of sand just sitting around in your ship. That's not safe. But in this case, these were actual sand dunes because they were being borne by wind, and they were piling up in these little ripples, which is all a sand dune is ultimately. It's essentially a sand ripple. But these were millimeters high, less than an inch. Whereas you can also have that are 20, 40, 60 feet high, or we'll say 20 meters high, is of non-Murricans. There might be some non-Murricans here.
That's weird. Do you see that this perfect linear thing is not a ripple? And I think
it's
at some
not
point,
a ripple in cross. It doesn't look like a ripple in cross section. So the cross of a sand dune doesn't look like a ripple, but that's because you're slicing it in half, right? So when you take a lithified sand dune, the sand dunes are ripples, but when one lithifies, when it becomes a rock, and now it's set in place, and you take a slice through it so that you can see the strata, it's not going to look like a ripple if you're looking at it on the side from sliced, so you can see the inside of it. Instead, what you're going to see diagonal bedding, and the reason it's cross bedding is because other parts of the rock are bedded the other way. That's why it's cross, because the sand dune goes up and it comes down, and it's the angle between that gives you the cross bedding angle, and those are characteristic between underwater and under the air, or in the air, I guess, bedding. And this, in fact, not just this, right? So there's the Navajo sandstone, there's the Coconino sandstone in the Grand Canyon. There's also a famous alien sandstone in Mongolia where they found the fighting dinosaurs, the Protoceratops and the Velociraptor, where the Velociraptor is kicking at the Protoceratops' neck, and the Protoceratops has its arm in its beak. That's why they're called the fighting dinosaurs, because it looks like they were fighting, and then there was a sand slide where a dune started to collapse and cover them. So we have lots of these Aeolian sandstones. Now, they're not the most common kind. Waterborne sandstone is more common. But a flood model has to deal with not only Aeolian sandstone, it has to deal with subaerial tuff, it has to deal with evaporite deposits, it has to deal with fine-grained sediments that don't have any flocculates. It needs to deal with the fact that neither the fossils nor the sediments themselves are hydrologically sorted in any identifiable way. And the thing is that, sure, you can find aspects of geology that are well explained by a global flood. That's easy. Sure, would a global flood result in layers? Yeah. So the fact that there are layers, okay, that's fine. That can go either way. Could a global flood result in folded sediments? Yeah, it could. So that doesn't really tell us anything. But one of the things that I found... oh, yeah, go ahead.
No, let me let you finish. I want you to finish first.
Oh, one of the things that I found in a lot of younger creationist examples of geology, where they're saying, "Hey, look at this group of strata. Look at this formation." What I almost never see is them going step by step through each layer and explaining not only how it was formed individually by a flood, but how it came to rest where it is relative to the other layers, and how all of them could have been formed in the space of a year by the same flood. Typically, they explain one or two features that could reasonably be explained by a flood, and then move on. And I'm saying that's not sufficient. You can't do that. That's not how geology works. I'm done.
Okay, I remember you saying that there hasn't been an experiment that proves that this is from a flood or could possibly be from a flood. I mean, you said there is a possibility, but because there hasn't been experiments done, you said it's not as strong as other evidence, right? Is that what you said?
Well, for this to be a flood deposit, it would violate our current understanding of physics. But the thing is, our current understanding of physics is based on experiments. So if you can show an experiment that violates our current understanding of physics, it just means our current understanding is wrong, and now we have new physics to investigate, but we also have a reason to believe something like this could be from a flood. So my message, I mean, not necessarily to you and Cindi, because you two probably on your own don't have big sedimentation tanks to work with, but my call to creationists, flood geologists generally, is like, guys, do the sedimentation experiments. Show us physically how it is that all these
tank big enough.
That was the point. I was getting ready to say. So this is this is the question I was going to ask, is that the experiment not been done because it's literally impossible to try to demonstrate what a flood would be like. Like you said, there's no tank big enough. There's no you said high pressure water. It's impossible, not impossible. We could literally try to pour, water into whatever, but how would we be able to do the experiment to demonstrate high pressure water to the capacity which we're trying to pitch the flood?
Yeah, it's a good question. So generally speaking,
miles and miles of sand at a time.
So, overall, once you have sediment and a cementing agent and whatever fluid is being used for transport, above a certain scale, which is not unfeasibly big for people who have the backing of, say, like an AIG, most depositional environments are largely scale irrelevant, where it doesn't matter if you're depositing over the course of 3 square meters or 300 square kilometers. The deposition is a local event that happens with individual grains of whatever sediment with whatever dissolved cementing agent in whatever water column happens to be above it. So it's actually not very important for sedimentation that you have horizontally expansive pools. It is sometimes important that you have deep pools, but the thing is, generally speaking, while you can in some cases make differentiations between deep water versus shallow water, the most important thing is, can an event like being described, where we have high energy, not necessarily high pressure, but high energy water, and the known types of sediments and the known cementing agents, can they form even on a small scale? Because the thing is, like I said, sedimentation is a fundamentally local phenomenon for each sediment, right? Each piece of sediment. A single bit of sand doesn't care how far it is to the end of the sand that's being deposited, right? It could be 45 miles, it could be 3 inches. That sand grain doesn't care. It's only caring about what's happening right near it. So that's one of the reasons why sedimentation experiments can actually be done, is because you don't need to have a pool the size of North America to show how sediments can form over that wide an area. You just need a relatively small one, which is a common thing in science, right? We're always scaling things up and down.
Well, there's nothing to say, for example, that the scientists working to try and demonstrate a flood would not have access to necessarily the same tools that other scientists currently have access to. On top of that, is like, to simplify Dapper's example, you can test gravity with or test what the effect a meteor striking the planet would have without actually having to strike at the planet with a meteor, right? Because we have good understanding, or we can scale up.
Actually, that's a great example. People use like basically specially designed guns to shoot metal slugs at rock and sand to look at how comet craters form, and then that information is then scaled up with, obviously there's some uncertainty because, sand isn't exactly going to be the same consistency and whatnot. But yeah, I mean, those are valid experiments that help show how craters form on like the moon or even on Earth. That's all I want, right? I don't need a huge city-sized scale tank. A tank that can fit inside of a small warehouse is going to be more than sufficient.
Basically, if you can get a hold of the tanks that they use for the filming of Pirates of the Caribbean, you'd probably be able to.
Well, they don't need to be that big. They don't need to be that big. They could be much smaller than that. Much smaller.
I'm actually not compelled by that. I feel like you do need to have continent scale stuff, and
why?
Yeah.
Do you see why that seems kind of
because if you look at, no, because when you look at the pictures that we were looking at, there's so many different things going on.
Do you want me to pull it back up?
Oh, she went out. Oh, okay.
Do you want me to pull up the picture again for you?
No, I have it in my brain.
For me, you can.
There's just so many different phenomena. You'd need a large area to recreate that kind of a thing. But anyway, I think you have, so saying is some layers of the Earth would lend themselves to a flood model and some layers would not.
Some so well lend themselves to a flood that is the general consensus, is that these things were in fact deposited by floods.
What would just to ask Cindi, because I don't want to get off of this quite yet. What would you think the minimum size be required to tell what was going on with this particular image? Like, would we?
Well, it's kind of like
in either way, whether for or against the flood, right?
Yeah. Well, I guess I could do the same to you guys and say, show me how that could be formed with wind.
Well, no, that's not what I'm asking. You said that you don't believe that you could use a tank of a smaller size to demonstrate. So I'm just asking you what you think the minimum size would be that you would find plausible.
I was looking at the dimensions of this landform. And I would think that it would have to be at least that size of that dimension of that landform. However, it's kind of like the arm bones connected to the shoulder bones connected to the. So even if the landform only takes up this much, part of what formed that landform is what's around it. And so I don't know how big the cause was.
That to me, then I have to go to the next question and say, well, if you need something that large to decide whether or not this particular formation can happen in a flood, to then demonstrate a flood, would you then not need to flood the Earth to be able to tell something that drastic of that size?
It's kind of what I'm saying.
So, but then why would you? Absolutely. There's no way we could do that. So, if that's the case, and there's no way we could possibly know what's convincing you, because it's clearly not that the experiment's been done. Because the experiment is what you're saying is not possible.
Because to me, it looks fluid. It looks like these layers are too perfect to be windborne. It looks like too huge of a scale. It looks like the grains that Timmy was saying would be airborne. So someplace over yonder is a source of these grains, and they're being eroded by wind, and they're being transported by wind and deposited. That's a heck of a lot of little things breaking off. And I feel like
experiments you said happened. He said that there had been experiments done to show the evidence for this.
Sure, yeah. Well, I'll drop the citation needed, but real quick before we move on. Before we move on, if that's the case and you're able to look at this and come to that conclusion, why that conclusion over others? What about the way you look at this image is more or less valuable to you than X, Y, or Z?
Well, basically, we're just talking about wind-borne or water-borne.
Well, we're talking about physics, right? And so physics has a plethora of whether or not gravity works, how different, because whether or not you decide there's a flood or not, we can all agree that the way things fall in water, like with the experiment that you did that Dapper was talking about, as well as we can look at a beach and we can see water pushing things. We can look at a desert and we can see how air pushes things. So those are, we all agree that air and water push rock around, right? So if in one way we can apply it and the other way we cannot possibly do the experiment, I'm just not sure I'm grasping why looking at this image and saying, well, it looks too perfect for X, Y, and Z reasons is viable versus our current understanding of physics.
So what you're saying is that Timmy is proposing that this formation has been experimentally done with airborne. Is that what you're saying?
What I'm asking is, what about your explanation is more convincing to you than Dapper's explanation?
I don't think the airborne has been experimentally proven, and just using my eye.
But you're coming to a conclusion, right? You're coming to a conclusion. You're saying this was a flood. So you're saying that yours is conclusive and his is not. And I'm just trying to bridge why.
I'm actually not.
It makes more sense for it to be a flood than for it to be airborne. I think that's what she's trying to say, right?
Okay,
is that what you're trying to say?
Well, I'm asking why.
Visually.
Okay, here's the thing though. That's a problem that I have with the whole video that you sent me, as well as this conversation. Cindi, neither of us are geologists. No one here is a geologist. No one here is competent to eyeball a photo of a rock and then tell anyone what it's made of, how it formed, how long that took. That's why all of us have to rely on people who are actually doing things like taking samples, examining samples, doing experiments, doing observations. And actually, I'm going to quickly say that for Aeolian sandstone, generally speaking, we don't need a sedimentation experiment because we can watch the sediment be deposited now without an experiment. So we simply observe that happening. It's happening currently in nature in many, many places. Well, basically any place there's a sandy desert. So
but not in
it's happening in the Gobi.
That's what I was trying to understand. Experiment.
Laminated aerial deposition is currently happening in deserts on Earth. And we can see that by, in fact, actually, this is not aerial, but you yourself in your video showed laminations that will eventually form in a sand formation if it lithifies. But yet we can do things like we can core sand, we can watch different types of sand deposited during different times of year right now in sandy deserts.
I mean, if you Google a picture of the Gobi Desert, Google a picture of the Gobi Desert. It doesn't look anything like it.
I'll pull one up. Feel free to go on. Don't wait.
Yeah. So the thing is that
I'm not trying to say I'm dogmatic on this. I'm just saying this is what it looks like to me.
But what I'm trying to tell you is, and in fact, it's one of the things that I put in the video that will be coming out on my channel is, look, I can find an island that looks like a dolphin, or a rock that looks like an elephant, or a mesa on Mars that kind of looks like a face, or a burn pattern on toast that kind of looks like Jesus. What something looks like, especially to someone who isn't an expert, is actually meaningless, right? It doesn't matter what it looks like to you. It matters, can you find actual science to back up the initial impression that you get? And the thing is, I look for it, right? Because the thing is, look, floods are often not often, but floods are an explanation for various rocks, right? So for all I know, no, actually, to be fair, I do actually know from eyeballing it, this is very unlikely to be a flood rock. But still, I went and checked, because the thing is, Cindi, you're not able to look at rocks and determine whether or not they're flood rocks. If I were to show you known flood rocks, I don't know whether or not you could identify them as such. In fact, I would be very surprised if you could, because I don't think I could rely, especially not from a picture.
Hey, Josh,
I have a question.
That is one of the rarer Gobi Desert shots. Most of the other Gobi Desert shots are primarily sand.
Yeah, I just specified layers, so that way we could actually see the layers of the desert.
But I'm not sure that if you see those dunes, if you cross-sectioned them, that they would be layered. I think these layers might be under the sand, and that the sand is eroded away from here. If you go back to the other ones that have all the sand and the ripples and stuff, that's what I was saying. Wow, that's way different.
I mean, this kind of sounds like special pleading.
Actually,
if you want to compare strata layers, we got to look at strata layers.
I have a question.
Well, no,
actually.
I'm saying
so
that
when
strata layers sand. That's the contention.
I have a really serious.
Go ahead.
I have a really serious question. I really want to get this out. I think it's really important. Okay, so are literally thousands of geologists out there right now who are going out, measuring things like airborne sand dunes, waterborne sand dunes, looking at things like seasonal variation in deposition and lacustrine, subaerial, fluvial environments, who are, in fact, in some cases, doing sedimentation experiments. And what all of them, and I mean all of them, are coming to the conclusion of is that this is the kind of thing that we see in deserts, and it's not the thing we see in floods, and that they could not find a good way to explain it via flood. Are they all lying? What is their motivation for getting this wrong? Because the thing is, if it would be possible for it to be a flood, we know that in some cases they do say, yes, this is a flood. Are they lying about what they see in desert? Are they lying about what they see in the rocks? Are they just really, really stupid, despite having gone through usually 6 to 8 years of schooling in this?
I didn't know that there was kind of a consensus, and if I Google pictures of a desert, that doesn't look anything like it. So I was just
a current desert right now at the surface isn't going to look like an ancient desert that has lithified and then eroded partially away. Those aren't going to look the same, because a currently forming desert sandstone is going to be at the surface, so you can only see the top layer, and it's not going to currently be lithified. So yes, it's not going to look the same. But that's kind of like looking at a baby and saying, well, this doesn't look like an old man, so it can't turn into one. Rock starts to look different as it does things like go through folding events, go through liquefaction, weathering, fracturing. All of these things change the way that a rock looks. Looking at the top of a sediment layer that's currently being deposited is a fundamentally different thing. It's just as different as you ever have one of those giant everlasting gobstopper candies? Have all the layers in the middle.
I think a good example would be caterpillar to butterfly. You're just looking at a chrysalis and you are like, well, I have a caterpillar, I have a chrysalis, and I have a butterfly.
If a desert with airborne sand looks like this, or looks like big dunes, it's not going to fundamentally turn into a perfectly laminated thing by time.
How do you know that? How do you know that?
Well, how do you know that? How would you know that it would?
because if it has things like seasonal changes in the sediment that are deposited into the desert, then at any given time, the top layer is going to look like a single roughly solid color because all of the sediment is being deposited on top because it can't.
Not the color, the ripples, the dune effect. So what you're saying is, if this is formed by air and not water, that even if the neighboring formation is formed by water, you can't have, a global flood would cover the globe. So if I've got a flood deposit here that everybody agrees is a flood, and you've got a wind deposit here that everybody agrees is wind, then you can't have a global flood.
I can't see both hands. Sorry, I'm not sure what you were meaning.
Sorry, I'm looking at the wrong image.
There you go. Okay. No, it's all right.
Let's say if you have a flood deposit here that everybody agrees is a flood laid down by water. And then you've got a wind deposit, everybody agrees it's laid down by wind. So what you're saying is, if this is wind, that therefore proves that there couldn't have been a global flood.
No, it proves that both could not have been the results. So what it proves is that both layers could not have been the result of the same global flood. And what that means is then, if we need a global flood to explain the majority of the Phanerozoic rocks, which is what all flood models proposed, all of the Phanerozoic rocks are interspersed with rocks that can and can't be caused by a flood, then that does rule out the option that this flood caused most of the sedimentation in the world. Now, there is another option that has largely been abandoned called the tranquil flood model, where there was a global flood that essentially left no record in the rocks. The problem there is that you can only add water so quickly to the globe while having it still be something that you could reasonably call tranquil, which is why most younger creationist geologists, in fact, I believe all of them who at least claim to be geologists, have abandoned the tranquil flood model.
I like the idea that the global flood was actually only like maybe 6 to 10 feet tall.
And all the mountains were just really, really short?
Yeah.
It's above the mountain.
This
is a cubit.
It happened no, the flood happened before the mountain formed.
Yeah. Well, and we'll go opposite.
Yeah. All right, so I'm just gonna
actually short.
I'm gonna put I'm gonna put a quick timeout on us. We're gonna give ourselves a little bit of a break. Chat will still be visible, but I just want to give everybody time to get a drink, go to the bathroom. We have been at this for over an hour, so I just want to let everybody have an opportunity to get their drinks, let the chat have an opportunity to get their drinks. Everybody take a pee break, and we will be right back in a minute or two.
How come I can't?
We're still gonna have hot mics, so everybody will still be able to hear us.
I want to see the chat. I can't see the chat.
Oh, you'll have to open up this video in your own browser, and then you'll be able to see chat. All right.
I was trying to see chat too.
Rock, paper, scissors, break. Man, I just wanted to leave the logo up, and it just did not want to work. Oh well, such is my tough luck. I have a problem, and I need duct tape to fix it, allegedly. Supposedly, that stuff fixes everything.
Duct tape does fix just about everything.
I no longer have a functional electric kettle that auto pops and ends.
Ooh.
This thing that I found is like, it is electric, got a wire, is kind of cool, gets really hot on the outside. I'm pretty sure it's probably a fire hazard, and that's why they don't exist anymore. But it doesn't turn off. So if I walk away from it, so I'm just gonna plug it in on my floor over here. And I'll just deal with it. It's fine. I don't have a stove kettle. I don't even have a stove.
Got a hot plate?
I do have a hot plate.
Then you have a stove that can work for a kettle.
Right, but I also don't have a kettle.
Well, yeah.
I could use a pot, but that, you know what that doesn't do? Doesn't turn off automatically either.
No, it doesn't.
Neither does a stovetop kettle. That doesn't solve my problem.
That's true.
I don't have a stove. I don't have a... Jesus Christ. See, this is what happens when Dapper doesn't, like, talk or mute. I had him, I had to work really hard to make it so that noise didn't come through 24/7. That was not easy. It was kind of easy.
Sorry.
Oh, sorry. No. Listen, this is bathroom break. It's all good.
Yay, so you're just back early?
Yeah. I couldn't get. I gotta fight. I'm gonna have to do another stream for members only where I play around on VMix and see what it can and cannot do, because I feel like I should be able to get that stinger to just sit up there for like a minute or two. If I can't, I'll just find life will find a way. It's fine. Oh,
what stinger?
Oh, this thing.
Oh.
And when it ends, it'll just go away. But I don't know how long it lasts. There it goes. See? Ta-da! And I'm gonna get that to pop up on its... Dapper's in the side chat on my YouTube account.
I have no idea what you're talking about.
You absolute weenie. The worst part about this is that he can do it to me, but I can't do it to him. But you know what? It's okay. I accepted that. You know what? I made my own bed and now I'm gonna sleep in it.
Can I tell you about the BK thing?
Yeah? BK thing? Yes. Oh my god, the BK Brett came. Oh my god, yes. Tell me about this.
Several weeks ago,
yes.
It was on the table whether I should do it or not. Timmy told me don't do it. AJ told me don't do it. Steve McRae told me don't do it. Who many else people told me don't do it?
What the hell? Steve told you not to do it? He told me to go talk to that guy. What the hell?
He likes Cindi more than you. I think we all do, Jen.
I mean, that's fair.
He was sending you to your doom, maybe.
I guess so. I wonder why.
Okay, so I decided that I really wanted to reach a Christian audience. This was supposed to be, they're victims.
Right.
Christians are.
Right. You're talking about Ken Hovind.
So yeah. And so I went on, and then I think I went on twice, and then he turned on me. He had Kent Hovind on the show like times. Kent Hovind brought on 9 false witnesses, and I'm just like, okay, I'm dead. Go ahead. I'm dead in the water. I will go away now. And then he turned his mind again and said that Kent Hovind aided and abetted Chris Jones, and that I'm sorry, Cindi, I made a terrible mistake. I want to make it right for you. And then Mary came out. Okay, so when Kent Hovind did all that slander,
yeah,
people came out of the woodworks. that have been quiet, saying, I don't want to get involved. I'm not coming public. Mary came public. Julie came public. Daniel came public. And so then we were all going to go on the Brett Keane show because that was for me. And then last night we were all on the show, started it out with my arch enemy, like leading the pack. And I get into the Deborah. I don't know if you, anyway. And then I get into the chat room and there's Sandra. And I'm like, you set me up. You set me up. It's supposed to be Mary and I being able to defend ourselves against the slander that Kent just did, and using the three witnesses, Mark, Julie, and Daniel, help defend our, say, look, Kent was lying on Monday.
Right.
And basically, he watered it down with some trolls and some enemies and he put a time limit that he didn't tell me about. He said, look, your hours, Kent Hoven's coming in the room now, you got to go. And I'm all, Kent Hoven has his own channel and you never told me it was going to be an hour. And anyway, so I said it was Mary and my understanding that we were going to present our entire case with all three of our witnesses before Kent came on. And then at the end of the show, he goes, I just feel like not fair. Kent Hoven was waiting in the wings for 20 minutes and this woman wouldn't let him in. So you just dumped on me.
That sounds like Brett Keane.
Yeah, that's about what I would expect from Brett.
So,
I'm sorry that happened to you.
Hey, Kaylin, welcome back.
Oh, I'm sorry.
Would you say something?
The good thing of it is, Chesh, Mary's out, Julie's out, Daniel's out, Mark's out. It's huge.
Oh, listen, if you actually want to take an opportunity and bring them all on, you're more than welcome here.
Thank you, sweetheart.
And I'm not going to flip-flop on you like a fucking asshole. Fuck that guy. There's a poll in the chat now, by the way. Yeah, about fuck Kent Hoven. And the options are yeah and fuck that guy. So...
The only
There's no option to show.
Listen, I don't give... Kent Hoven, Brett Keane, what are you going to do? Suck my balls.
They're going to come all the way up to Canada and spout nonsense at you.
Oh no, I don't care. I don't leave my house.
No, on Wednesday, I went on Inspired Philosophy, and that was like, oh my gosh, this is like a breath of fresh air. Like somebody who's actually making sense and handling it properly.
Right.
It was such a blessing.
That's good. Well, I'm happy that you got the opportunity, and that your other friends have found a voice. Unfortunately, Brett Keane. So maybe bring them on to someplace more credible.
They're not going on there anymore.
That's a good call.
Yeah,
3 out of 4 of them have told me I'm not going on anymore.
Hey, listen, because we disagree about some rocks does not mean we don't like you guys.
Oh yeah, there's way more important things than agreeing about rocks, and one of them is, Cindi, you being able to get your story out there and not have people betray you by doing things like, I don't know, kicking you off so your abuser can come on the same stream that you're on.
Big yikes.
Not okay.
It was just like,
I didn't know that they knew about Kent.
To give him some credit.
Oh yeah, we know about Kent.
What?
I said I didn't know they knew about.
Yeah.
To give him some credit, when she was on and I said, Brett, you said this was my and Mary's time to present evidence, and there's 5 of us. We only have so much time. No, this is not the time for Sandra to come on and dearly. Anyway.
Counterpoint, he gets no credit, and fuck that guy.
To his credit, though, what I was trying to say is he did drop her off.
See, even Puck's not impressed with Brett Keane.
You You tell him.
What kind of dog do you have, Chesh?
Huck is
What kind of dog
trying to read.
is a cross between a shepherd and a border collie. He is considerably large, and he's big friendly boy. I don't know if you guys can see him right now.
No.
He's right there.
No, there he is.
Wow.
Was that him barking? I thought him barking. He's laying down.
Okay, but to put it in
He's got that
context,
old gray nose.
Chesh is like 3'7" or something, so you know.
Smitty's funny.
He's
I
like
can barely read.
he's like 120 pounds. The dog weighs more than I do.
Really?
Yeah, he's quite big.
Wow.
Wow.
You guys want
So
to
you're-
actually
I-
see him? I can see if I can get him to come over. Puck, come here.
I'm a little dog person, but I thought about getting a bigger one.
Man, he was not supposed to be
And then
this
she
big.
thought about her shoes.
What?
Then you thought
Fuck
about
being
your-
lazy.
I think he's getting his something. You getting your ball, buddy? What are you doing? Come here.
If
Come
you get
here.
an older one, put your shoes
I would
in.
like to see your face eventually, Timothy.
This is my face. What are you talking about? I'm a dinosaur.
Because no, I'm a very personable person. I like to see, connect. I'm talking to a dinosaur. Like,
Yeah.
I feel so dumb.
I'm a very,
shy?
very smart dinosaur. Me? Not particularly. I
Yeah.
don't think I am.
okay.
He's got a
I'm
channel
not gonna
philosophy, and
press the issue.
that's what he's about.
Yeah, I do have channel philosophy. It's a very strict one too.
Oh, you do? Is your face shown?
Actually, I think technically it was once on screen, but that has been cut out. But I have told people that I will do a face reveal if they get me enough subscribers.
I didn't know you do philosophy though. That's more up my alley. I'm more so I like philosophical.
Well, I have. I don't.
Boy.
Yeah.
I don't so
That's why I
much
kept telling
talk
Cindy, I
about
was like,
philosophy on the
"Science."
channel. I have a philosophy for the channel.
But
So my
yo,
channel is.
You want to talk philosophy? I've got you covered. You send me a message later. You let me know what you want to
Okay.
talk about. I got a whole like back
That'd
pocket
be
full of
good.
philosophy nerds.
A stable of
Oh
philosophers.
my gosh. That's
Yeah.
perfect. Yeah, I do have my own channel, but it's still growing.
Aren't we all?
Obviously, I'm sure like all of ours are, but yeah. I talk about I haven't been doing much of the philosophy stuff, but I more so talk about, my faith and things like that. But I definitely want to get into I actually need to be a guest on my channel too. So you guys too, I want to get more connected. I'm so out of the loop. I really want to be involved.
Has
It actually
anybody
came
told
down-
the drunken peasants that Cindi was talking to Brett Keane? Because
Oh,
they
I
need
sure
to
haven't.
know about this.
set me up. Because what?
Because they need to know
They
about.
need to
Listen,
know.
Ben and Billy are the best boys. They're the sweetest boys. They will absolutely love you. But they need this is information that I will guarantee. I'm making sure that they find out about this. Needs to happen.
You're not crucifying me, right? This is.
No, I told you they're the
Okay.
best boys.
They don't bite.
Oh, they definitely do. Just they just wouldn't bite you. They have a particular palate. You're not
They
you're not their
can
type.
they can be mean, but you're not the kind of person they would be mean to. Now, some of the other people we've talked about today, they might be mean to.
Oh, absolutely. They fall under the same
Yeah.
kind of heading that I do. I am not a very nice person when provoked. Don't
Yeah.
provoke me.
Quick
Yes.
question. Do you guys have Instagram?
Yeah, but
I do
I
not.
really don't use it.
I have a
Generation
Facebook that I don't
X.
use, and I have a Twitter that I do use,
Use a Twitter.
and then I have a Facebook that I do use, but that's my personal Facebook. And I don't
Alright.
actually even use that all that much.
Let's jump back into our topic here.
Yeah, rocks.
Rocks.
Are we on live
Every-
still?
Yeah, we had hot
Oh yeah,
mics
we've
the
been live this whole time.
Yeah.
I didn't know that.
I have a proposal. I have a proposal.
All
Hey, will
right.
you get that verse for me? And I have a proposal for you, Dap.
Hell yeah,
Yes,
let's
I'm
go.
so excited for this proposal.
Let's
It's actually
Okay.
good. Yeah.
Are Dapper and Cindi gonna get married?
Yes.
I'd be a little
And I
jealous.
could move into his
but
apartment for $500 a month.
I'm gonna come visit.
Okay, so
Yeah.
Yes.
Oh wait. Go ahead, Cindi. No, I'm sorry. Go ahead.
In my model,
yeah.
Okay.
the wave in Arizona, maybe I'm wrong. Maybe it is Aeolian. But in my model, the whole planet doesn't have to be. Okay, so with your inland, what do you call it? The inland sea. There's going to be beaches on there. So
yep, we have paleo beaches. Mm-hmm. Yeah, we have paleo beaches. There are places where you can find the rocks that are preserved beaches. They're complete with things like ripple marks, tidal depositions, in some cases fossilized footprints if the seas are receding. We have what are called, so there's vertical extent, right, and horizontal. And so there are places where we have horizontal formations like the Chinle Formation that goes from shallow marine to coastal to fluvial, and then in some cases to lacustrine across its horizontal extent. So yeah, we have all of that. All of that is a real thing that you can find in the rocks right in North America, where I believe all four of us are located, right? Caitlin, you're in North America, right?
Yes, I'm sorry. Yes, I apologize. I was reading something.
Oh, no worries. So yeah, all of that is stuff that's already there.
To me, it doesn't look windblown at all, but I will give you it because you think that it's more proven. And I think that doesn't exclude the flood model, the global model. And in fact, I was reading the story in Genesis today just to be prepped a little bit. And there actually, at the end, when the waters were going to be abated, God did send a great wind. So it doesn't exclude to me.
And I was thinking, the flood doesn't necessarily mean that different like rocks or sediments, I'm trying to use the terminology right, like it doesn't mean that it excludes that there could have been wind that caused like certain forms and things like that.
I agree.
It could be, yeah, like it actually could be both. So that, like, as you were talking, I was like,
yeah. So the step then at that point is if you do end up agreeing with geology as it is currently practiced, that certain strata couldn't have been formed by a flood and therefore they weren't, you then have to come up with a flood model and show why it resulted in the rocks that you believe were caused by a global flood, why you believe that those particular rocks represent a global rather than a series of local floods, and then yeah, I mean that's the thing. That's a perfectly valid thing to do, to come up with a new model. If the current model that you're working with doesn't seem to be working, which there are two big competing flood models right now. There's ICR's flood model, where basically all of the Paleozoic and Mesozoic rocks, as well as most of the Cenozoic rocks, are all flood. Then there's the AIG model, which was proposed and formalized by Andrew Snelling, where all of the Paleozoic and Mesozoic rocks are flood, but then all of the Cenozoic are post-flood. And neither of those are consistent with the idea that, say, the Navajo sandstone, which is a Paleozoic rock, is windborne. Because under both of those models, those are actually formed during the increasing stage, where the water level is going up. So fine, that's great. Reject that model. But then the next step is you have to formulate a model that does fit with that information. And I'll put this, I'm rooting for you, because quite frankly, I would love to have proof of a global flood. I mean, I didn't stop becoming a young Earth, or stop being a young Earth creationist because it wasn't attractive to me. That wasn't the reason. I didn't want to do it. And so, hey, if you found actual evidence of worldwide flood, that's great. However, I'm currently skeptical that a viable model will be constructed. But I am happy to hear you say that.
Well, sweetheart, you have to understand that. Well, and I think back to this because you don't like it when we call upon a miracle, but the Lord doesn't work. The definition of supernatural is not natural. He doesn't think like us. He doesn't operate under our, the world is going to spontaneously explode. and have the plates break open and have waters gush out, it's not going to be a spontaneous natural occurrence.
I actually think
It's
invoking
got to have
miracle.
a cause.
I actually think invoking miracle is probably one of the more convincing arguments to me, because it's just like, listen,
honestly,
go ahead, Dapper.
Honestly, if you just want to say the reasons that it doesn't look like a global flood are that there was a series of miracles that made it not look like that, then my only response is, one, well, okay, but you have to realize why people who are not already independently convinced of your theological positions are going to find that nonsensical. And two, you also have to recognize that you now believe in a God who arranged everything to make it look like there was no flood, which I personally think has
You can't say that.
I think you're
misunderstanding. There was tons of fluvian deposit.
Well, it's a matter of saying that. Sorry, I'll let you go right after. It's a matter of saying that, hey, this can be explained in other ways. If you want to then say, instead of these natural ways that we've posited, and you want to say, well, actually there was a flood in between and God did it, but he made it either look like this, or the method which he used for whatever his reasoning is. He's God, he's beyond us. We may not know why he chose to make things appear as if they were natural happenings, or if he manipulated existing natural processes to however you want to decide your miracles work. The Dapper's point of would still, I mean, you can certainly do that, and it's convincing from a theological standpoint if you believe this initially, but there's going to be a disconnect there is what I'm basically getting at. Sorry, go ahead.
I think Timmy would actually go so far as to say that he feels that the science shows that it's not feasible for there to be a global flood. Therefore,
without
the whole
miracles.
Thing, I don't see it that way. I see that there's a quadrillion evidences for a global flood. And maybe a few we couldn't.
But do you also see that there's natural, like the natural reasons are also plausible and reasonable as well?
Yes, and I think that the Lord did do it using
that's what I was about to say. I think that's the point, that I think you're misunderstanding what we were saying, is that wind is not excluded. Like the forms, like the layers and things being formed like that is not excluded from our flood theory. It's just saying that what you are seeing as wind, I guess, like the science that proves, or like the evidence we have, the experience that we have that shows that wind, and the explanation that you gave is what could have caused those layers, is in addition to like the possibility of the flood as well. So our theory for the flood, like, I guess we came to the realization, Cindi and I, that you might be right, that possibly could have been wind, or other layers could have been formed, could have been wind, but the flood is also possible. So I guess there's both. We both have reason to believe. You know what I mean?
There's also like
ecosystems within the globe.
There's also a jump you have to make that then says, okay, well, if we have this that's flawed, like, let's say they're on equal footing, right? So let's say you have equal evidence of the flood and you have equal evidence of naturally occurring
non-flood.
Right. So you've got flood and you've got no flood, and let's say that hypothetically that you have an equal amount of evidence on both sides, right?
Mm-hmm.
Why do you choose one or the other?
You know,
well, that's what I mean. Like, we're not really Go ahead,
this is actually a really crucial issue. And it's not just for the flood, it's for many, many different things that people fight over. And the bottom line is that we do believe that the scriptures will be borne out by science. We do believe that the Lord did speak, that he did write a book, and that he is, and we are.
Now it's deeper than just the science, is what I'm saying, is because even the scriptures are giving explanation of wind, right? Like, it literally says even after the flood, okay, the Lord caused the great wind. There were different times, like there's specific like explanations. And so what I'm saying is now okay, anybody can sit here and say, oh, that was caused by this, that was caused by this. But the Bible is saying like, okay, this happened. So now where do we go from here? I guess it's like, how do we know like what really caused it? You know what I mean?
So you're saying the tipping of the scale for you personally between the both of you is that the deciding factor about whether or not you believe one or the other when there is equal evidence to both. So now you're taking the Bible out of
the Bible.
Well, you're taking the Bible out of right, but you're taking the Bible out of your evidence now. Because you're saying it's the tipping thing. Because if it's the tipping thing, then it cannot be part of your equal parts, right?
I gotta understand what you mean by that.
Okay, yeah.
Saying if we just look at the science and we don't consider the Bible, would we still feel like they were equal?
Oh, I get it.
Yeah, well, I'm saying that if we're saying we're working with equal, hypothetically, equal amounts of evidence, and you say the tipping point is the Bible, you're removing the Bible from that evidence. So if you're using the Bible as part of your evidence that equalizes whether the flood is more or less likely, and then you use it as your tipping point that convinces you, then you have to...
I see what you're saying.
Right, you're removing it from that evidence, and then would that not then tip the scale against it? So either you see what I'm saying? So it's either going to...
I still...
Right.
I think I get what you're saying, but I still like personally think with some of the pictures that I've seen, like a flood makes more sense, like even aside from the Bible, like not just because the Bible said it, but like
now we're throwing out the hypothetical, because with the hypothetical we're saying, hey, listen, this is basically what you're saying is
it makes more sense. Yeah.
So you're basically like, based on your current level
of
knowledge, this is what.
Yeah. I can only go based on like what you guys are explaining.
I'm really going to say the visual thing is a problem for me, because, like I've said, no one here, in fact, not even actual expert geologists with decades of experience, nobody in the entire planet is qualified to eyeball some rock and then say what probably it is composed of or was formed by. This is something that, to do it at all reliably, takes almost a decade of training. And then even after that decade, you will not be able to simply look at some rock and have a good idea as to how it could have formed. There will be some things that you can eyeball and say, well, it couldn't have been this, right? Like if you see... So
I disagree. I disagree.
Okay,
so if I pulled out a
entirety.
If I pulled out a rock right now, any rock, would you be able to tell me anything about that rock? Or where it came from?
Yes, but we're talking about formation. You can see like
any rock,
picture.
any singular rock can be considered a formation. Formation is like it is in the form of this. So if I just pulled out a rock from my pocket,
like for example, the Badlands, you see all the layers. Sorry, where's my camera? All the layers built up, and then you see some washed a whole bunch away. I mean, that's a large scale.
Right. So if I said, here's a rock, it has its history is all that you can see. Everything about this rock. Can you tell me anything about what's happened to this rock?
I could probably tell you what it was. I could probably tell you how soft it was. I could probably tell you, is it metamorphic or sedimentary? But I'm not sure. I don't need to know everything.
Cindy. Cindi, how would you distinguish between a subaerial tufaceous sandstone and a marine tuff?
I really wish my D&D dice were made out of rocks.
Like, because here's the thing, right? You say you think you could distinguish whether it's igneous or not, but how would you do that? What are the characteristics that would tell you that this rock in particular is basalt, for instance? Like specifically,
well, sandstone is made of sand, is lithified, and lava rock is completely different.
Okay, but specifically, what would you look at? Like, right now, how would you describe sandstone from just being able to look at it as being different from basalt?
text, color, how much does it granulate
what color
or
is
fall
basalt?
apart?
Well, you can't do that because you have to just look at it. So, what color is sandstone?
Wait. I don't have to be able to identify every rock in order to pass this test, okay?
No, but we're
so that's the thing, though.
asking you if you're using a picture.
Those are
of
very basic kinds of rocks.
Yeah, if you're looking at a picture, how much can you possibly tell about a rock, an individual rock, let alone a formation? As a formation is going to have way more information that needs to be dissected necessarily, depending on what you're looking for, right? So if I just showed you a picture, how much could you possibly tell me? So if you're looking at the Gobi Desert, and you can see the difference in the colors in those pictures, how could you visually know what individual rocks, or we saw those different strips. Just by looking at those strips, can you tell me what kind of rocks those are?
I guess I'm just saying that there is an element to common sense that doesn't have to be PhD level. And there's other things that do have to be PhD level.
The problem is common sense is what tells us that the Earth is flat, that heavier objects fall faster than lighter objects. I mean, the experience of science basically
telling that the Earth is flat.
Well, are we
really does. That's been
yeah, that's a long-standing argument.
Tells you, if you're sailing on the ocean blue, if you don't fall off, the Earth is not flat.
So, Cindi,
are
a general
we
way
get
to know
Cindi
if something
to argue
is
with a
sense,
flat earther? Because I'm here
we should.
For it.
So here's the reason I say that common sense tells you the Earth is flat. It's because
is Timmy a flat earther?
No, he's not. Every culture that we have records for their cosmology of before the Greeks were the first ones to find out that the Earth was round, thought that it was flat. Because when you look at it,
no, honey,
it doesn't obviously look flat.
A group of people thought it flat. That doesn't mean everybody else thought it was flat.
The Egyptians thought that. The Greeks, before they discovered it wasn't, thought that. The ancient Hebrews thought that. The ancient Mesopotamians thought that. All of the groups for which we have records. No, I didn't say every. I said all the ones for which we have records.
So Mayans had their temples pointing out at the stars. They knew more about the stars than we did.
So before we get too off track, when it comes to common sense, too off track,
common sense is an extremely bad guide at science. Science has been the history of abandoning common sense in favor of rigor.
But the question is what are you going to consider in your priority scale? Do you prioritize somebody who studied this for a living and their ascertaining of data and information? They've traveled to the place, they've been there, they looked at it, they dug it out, they saw it, they looked at it through different radiometric dating, all the way to looking at it under a microscope, to running experiments, or do you put your common sense of looking at a picture over top of that? What do you prioritize, right? Sorry?
I'm not going to argue with a guy who has solid proof.
What?
I'm not going to argue with a guy who's got solid proof, but I do believe that there are scientists who study and test and whatever, they can be wrong.
Oh, sure.
Just like I can be wrong.
Right, but they're not wrong based on common sense. They're wrong based on further investigation.
Or both. Because if you start with a presupposition that's wrong, you're really trying hard to prove it.
But that's you! You're starting with a presupposition.
Yes,
that's not geology.
That's not geology.
That's not geology, though.
But you guys are missing the point that if you start with the supposition that the flood could never have happened, and therefore we have to go along this trail.
But
that's not what geology did. That's not geology. It's really not. It's really not. No, it's really not. The fact that there was never a global flood.
You can't judge the entirety of a field of science dating back hundreds of years by your imposed intention or motivation of a handful of people, right?
So Cindi, the reason that geology currently rejects a global flood is not because they decided that at the outset. At the outset, there was no conclusion about a global flood drawn, although many people presumed that it was likely because it was recorded in the Bible, and also at this point they were beginning to understand that there were other Near Eastern flood myths that were similar. But when it was investigated, it became very obvious very early on that a global flood did not explain the vast majority of the rocks evident in the Earth. And since then, that conclusion has only been reaffirmed. No one set out to disprove a global flood. The most that happened was some people said, hey, what if we don't assume it? What if we just say, let's just go where the evidence goes? And the fact is that for about 200 years, consistently, anyone who has set out with actual training in geology, without assuming a flood, has come to the conclusion that it is impossible and that flood models are nonsense.
That is not just,
it's literally the actual history of geology. I mean, that's fine.
I really don't.
Cindi, at this point, you're just denying reality.
I would have to ask a question.
You can read the geology papers.
Time out. If you're going to say that that's not what happened, what happened? And can you...
Yeah, why are the historians lying?
Do you have a citation to that? There it is. The citation needed.
Not on the top of my head.
Yay!
I mean, and that's fine. I'm not
fair,
expecting you to pull like all of this information out of your butt. But if you're going to make the claim that Dapper is not telling the truth or doesn't have the information about the way geology has been throughout history, and you're saying, in fact,
no, I did not say that Dapper was telling the truth.
Well,
It
sure.
was meaning to imply that what he was saying wasn't correct, but he could be mistaken. I didn't insinuate that he was lying.
I didn't think you were trying to say that.
No, I'm more going on the extreme side of things. But if that's the case, why do you think that? Like, based on what? If you think he's wrong, what are you basing that off of?
They used to believe that all the layers were from the flood. And that whole business about Lyell and stuff, it is very similar to what Kent used to teach. They were trying to disprove the Bible.
Who was?
So, Lyell.
Oh, okay.
So the thing is, Lyell said that he wanted to separate the science free the science from Moses. But the thing was, Lyell, his entire life to his death, was a devout Christian who, in fact, believed in things like the death and resurrection of Jesus Christ. He believed that there was at least some historical backing for the majority of Genesis. But his goal was to say, okay, look, we cannot simply take it at face value that this is how the world works if we want to investigate it openly and honestly. So instead of assuming a flood, he simply did not assume that there was one and then looked at the rocks. It's openly in his writing. He remained a Christian his whole life. His goal was not to disprove the Bible. This was a man who deeply believed in Jesus.
This is also an example of one person posited, not geology, the study of.
Well, I don't think everybody very often. And I've never said everybody. I said some.
The only reason I'm kind of getting onto this is that your reaction to Dapper's explanation was appeared to me to be very reactionary. It seemed to be very much of like a snap, like a very sharp, right away denial. So I'm just trying to like maybe work backwards to find out like, if you started here, can we show our math of how we got there?
Well, I think what he was trying to say was that science has proven that there's no flood. And I just don't think that's true.
I mean, proven in the strictest sense, no. However, for there to have been a flood, we would need to be fundamentally wrong about almost all of physics and chemistry. And that is unlikely. I mean, fundamentally wrong. Like, we would have to be wrong about the very basics of how almost everything works in order to accommodate a flood.
It sounds to me like what Dapper means when he says like, hey, listen, if you want to disprove or you want to prove whether or not a flood took place, you don't want to be looking at pictures of strata. You actually want to be looking at physics, and you want to be looking at chemistry for errors.
Well, I'm not qualified to do that.
Well, I mean, none of us are qualified to look at the pictures of the rock either, so you know what I mean?
So that's true. And the thing is, there are people who are, though, right?
Sure.
Like Steve Austin. Steve Austin is qualified to do this. Well, yeah. Andrew Snelling is qualified to do this. Michael Ord is qualified to do this. The curious thing to me is that rather than doing these things, they blatantly lie in fake peer-reviewed journals. And when I say blatantly lie, I mean to the point of Andrew Snelling putting people, his students, in front of rocks to hide the fractures that in his paper, including those pictures, that he says those fractures don't exist. And his evidence is the picture that he shows where he literally hid the cracks with students. Or Steve Austin lying about the capabilities of the lab that he sent rocks to be tested at, when the lab openly said that if he sent rocks like he sent, they couldn't give meaningful results. And then also, when called out on the fact that the only one of his samples that wasn't obviously a null result from the lab also obviously had things that were morphologically consistent with xenocrysts, he was just like, no, that's not it. Further explanation. The people who are qualified to do this on the young Earth side don't even try. They literally just spend their time lying. And when I say lying, I mean I can prove that they know better and that they deliberately misrepresented what they found to the point that some of them have been banned from doing geological research in areas for lying to the US government about their methods.
Well, if you're correct on that, because that is not how I want to run things at all, and I don't think that in order to prove the Bible, you have to lie.
So I'm not going to take a position on that one, because that's part of my channel philosophy, is that like I'm not here to prove or disprove the Bible. That's not my thing. However, it is concerning to me that not only when I look at it, but when I talk to geologists, of whom I know a fair few, right? Like I go out of my way to get to know scientists in various fields. I know biologists, I know geologists, I know paleontologists, I know some physicists. And when I talk to geologists and I say, hey, how does this look to you? The universal result is that this is the kind of thing that would get an undergraduate student expelled if they submitted it. Because it's deeply dishonest. It portrays a complete lack of concern for the actual data. And that's what happens when the professionals are doing it, people who are qualified. So,
no, wait a minute. Are you talking about specific things that Snelling or Austin have done, or are you talking about holding the position that the flood is real?
No, there's specific work. And also not just them, also people like Michael Ord or there's another one whose name I forget. But
I'm not going to stand up for lies. I don't need to stand up for lies in order to defend my position.
It's a question about. Yeah, it's what Dapper's getting at isn't necessarily about the individuals. He's more getting at that there are geologists that are qualified to do what you're trying to do. And they don't, and instead they lie. If that's not necessary, why do we not see any geologists on the side of the flood or the side of the Bible doing things that you're trying to do?
I can't answer that. And I don't know that it's definitive. I mean, I don't know every single one.
Oh, I'm not asking for specific individuals. It's more of like, there seems to be a problem here that is sort of like a larger kind of...
you think I'm rejecting this? Okay, now, when I was a geography major and I had geology classes, I would sit through and listen to what they were teaching, and I would go, that doesn't make sense to me. Okay, so I'm differing with my professor. Does that mean I'm evil and throw me out?
No, I would not say that.
Sometimes
I think it's
pretty normal to not. Sorry, Cindi, we can't hear you.
You're breaking up, Cindi. Can you hear us?
Yeah, I can hear you good. Sorry.
Yeah, you were just breaking up there for a little while.
So I just want to make sure we caught what you said. You had said that you were differing with your professors, and would that get you kicked out of class, or like if what they're saying just doesn't make sense to you? And I think both Dapper and I would agree that if somebody is kicking you out because you don't grasp a subject, then they're not doing their job. The whole point of school is to teach you things that you don't know or don't understand. And so questioning your professors is normal.
Well, you have to concede that professors are not always right. I think everybody would concede that.
No, I agree. But the thing is, when it comes to what the science ultimately is and what ends up being taught in classrooms, because science classrooms, even in colleges, are downstream of where the science is actually happening. Right? The science is happening in a combination of experiments, field work, and papers that are written about those two things. And the thing is that
there's degrees of
whenever
removal.
I check, yeah. But the thing is, when I go and check the geology about every single formation that, say, was in your video, which I think is now linked in the description.
It's in the chat right now. It'll be in the description when we're done.
There you go. Okay. Every single time I looked it up, because the thing is, I did that every single time. Because I know I can't eyeball these. I don't know what I'm looking at. No one does. Even if I were a geologist, I would still have to look it up. And in every single case, there were elements of this formation that you were presenting that precluded the idea that the rocks you were showing were formed in a single flood. And when I say precluded, I mean, in order for it to have been a flood, we would have to be fundamentally wrong about just things like how water works, how gravity works.
Timmy, that is not true.
I mean, it is
expensive. Say that
why not?
What in that video was not laid down by water. I think you already conceded earlier that the majority of sedimentary rocks on the planet are laid by water.
Yes, but deposited by water and deposited in a flood are not the same thing.
Well, honey, a flood doesn't have to be one single, because we already know that it's going to be having a going in and a coming out and a settling around. Where it stayed there for 150 days.
That still doesn't mean that you can get fluvial or lacustrine deposits during any part of a flood. Floods are not synonymous with water deposition. There are types of water deposition that, as far as we know, physically cannot be the result of a flood. And if you want to overturn that, or if anyone wants to overturn that, they're going to have to do a lot of work in geology and physics to show why it can. And we already went over some of those reasons why it literally is currently impossible with our current understanding.
What was the other one besides lacustrine?
I also said fluvial.
Fluvial just means flow, water flow.
No, it specifically means from a river. No, so fluvial literally is from Latin fluvium for river.
Okay, so either river or lake. Why are those excluding a flood? A worldwide flood is going to leave lots of lakes.
A worldwide flood is not going to be called a river.
Right. And the reason is because
after the water comes off of the land, there's going to be low spots that are going to have the water stay in them, which will be lakes. There's going to be the remnants of the flow off, which are now rivers. It's not mutually exclusive at all.
We're not talking about after the flood. We're talking about things that are in the middle of what all flood geologists are describing as flood rocks. If the only place we found lacustrine and fluvial deposits were at the top of the Cenozoic, then I wouldn't have an argument there. But they're happening not only during the Phanerozoic, they're happening before the Cambrian. Because one of the things that young Earth geologists almost never touch on is the extensive terrestrial deposits from before the Cambrian. Right? We have all these same kind of deposits before, during, and after, and there is no obvious difference in the depositional environments from before the quote-unquote flood and after.
Are you talking about the great unconformity? Because there's a great unconformity underneath which is not sedimentary.
Yes, in the Grand Canyon, that is correct. Actually, it's not entirely correct. The Grand Canyon supergroup does in fact include sedimentary rock. So there's things like the Vishnu schist and stuff that are not sedimentary, it's schist. But the Grand Canyon supergroup does include sedimentary rock from before the Cambrian.
I'm having trouble
understanding. And also, the Great Unconformity is not a universal phenomenon.
I'm having trouble.
Are you sure?
Yes. It's an extensive phenomenon, but it's not a global one.
How sure are you? I need a scale.
The Great Unconformity, according to what I understand, is, okay, there is a line on the planet called the Great Unconformity, above which is sedimentary, below which is not sedimentary.
That is an incorrect understanding.
Why?
So the Great Unconformity is...
Before this time, so, it was not a flood. Above that time,
that would imply that. That would imply that if that were a worldwide phenomenon. The Great Unconformity is not a worldwide phenomenon. It exists at the Grand Canyon and in locales near there, but it is not a global thing. There is not a single Great Unconformity across the world that separates the Phanerozoic from the Proterozoic, with only igneous rock below or metamorphic below and sedimentary rock only found above. That is not how the Earth is working. The Great Unconformity is called the Great Unconformity because it's very obvious and very significant at the Grand Canyon, but it does not exist everywhere. And there are many, many sedimentary deposits from before the Phanerozoic. So your understanding of it is incorrect. And that's like, I mean, it would be the kind of thing where I would suggest, like, just look up the Great Unconformity, because I strongly suspect you've been lied to about it.
There's also, like, a large amount of just, again, as Dapper's been saying, there are things that you can find that say, hey, like, yeah, that looks like it was a flood, or hey, yeah, that looks like there was a river there, or hey, that looks like this. But those things do not remove those options. So, like, hey, this looks like there was a river here at one point doesn't mean, yeah, there was a flood, that's why there was a river there. Right? So, like, these things are not precluded or discluded due
also,
to...
there are sedimentary rocks below the Great Unconformity in the Grand Canyon. So, the Grand Canyon supergroup consists of several strata, I believe it's 4, which are all Proterozoic sedimentary layers. So this is sediment that was deposited before the Cambrian. So we're talking about, like, the Neoproterozoic and the Mesoproterozoic. So the Ediacaran, the Cryogenian, the Tonian, Stenian.
A lot of information to break down and process.
That's true.
Every one of Dapper's videos is like this.
Well, the other thing that very much concerns me is you seem to be advocating that if I don't accept mainstream, therefore I need to be shunned in some way.
When did anybody say or imply that? And if they did, in what way?
You're allowed to not agree with science.
Well, you said something about rejecting science and that I should be kicked out, or the teacher would be...
No. What he said was Snelling lying in his paper would have gotten him kicked out of school, because lying in your papers, like plagiarism in English class, gets you kicked out. Lying about data in your papers in science...
we were talking about lying.
Oh, no,
I did not think we were talking...
My apologies. I might not have been clear about that. When I said that Snelling should have been kicked out for this work, it is specifically because it is directly dishonest. It's not because he comes to an unorthodox conclusion. It is because the data he represents were not the data that actually existed. Yeah, okay.
We would both agree.
No. Simply being someone who disagrees with science is not a good reason to be kicked out of anything.
No. And it's not that you don't grasp the subject. It's that you are compelled by the argument and you don't agree. I really hope that
depends a
means.
little bit on context, right? If you're in university, right, and you're in a master's degree program for, let's call it evolutionary biology, and you say that you're not compelled by the evidence of biology, in your papers that are supposed to be explaining and telling people why and how you understand the topic you're studying, it is likely that you're going to fail out of that course because that's not what you're there to learn, right? So what you personally believe is irrelevant to whether or not you can get a degree in something. It just means that you have to understand the science and understand the conclusions based on that science. Now, if you disagree with the premise, let's say, that's fine, but just disagreeing with the premise does not demonstrate whether or not you understand the premise and the science, right? So you can demonstrate that you understand evolutionary biology without believing that it's true, right? So your belief does not predicate whether or not you can get a degree or not. However, if you're like, this is all bullshit and I disagree about it because whatever your reasons are, then it's likely that there's a fundamental misunderstanding about what you're even in the class to do.
Well, I wouldn't take an evolutionary class. If I were going to study biology means bio, which means this life, the study of life. So I'd want to study living creatures.
Well, there's certainly you can study marine biology, and it's likely that there would be a course within that would cover evolutionary biology to be like, well, where did this creature that we're studying come from, or where is it going? But there are different fields of biology, right? So, I mean, if you want to pick a different field, that's fine. It doesn't really matter. So, like, I could take a master's degree or go to school and study theology and say, hey, listen, this is what I've learned, this is what I understand, this is what I've been taught, without believing any of it.
I'm feeling in my gut a huge divide, and I don't want that to be. And in the same way as we've always said, atheist or yuck, we don't care. We don't want to divide. And unless there's some kind of a moral issue where somebody is lying or betraying or harming, I don't divide over that.
Well,
and in fact, after me and Timmy had a 5-hour conversation, the very last thing Timmy said to me was, you need to allow me to believe the way that I believe. And I guess I would have to do that.
And I'm not here really to like convert anyone to anything or out of anything. I'm only here to say, here are the reasons why this argument fails, and in a context where really we're all, I think, here to discuss this on the basis of, scientific merit and things.
Well, I mean, like we said earlier, or at least what I said, because God did it is probably what I believe is one of the more compelling arguments when it comes to whether or not a flood occurred.
One of the things I want to point out is that my concern for people, my level of care for them, whether or not I'm friends with them, does not primarily depend on whether or not they agree with me about rocks. That's pretty unimportant to me in the long run. So, I mean, there's certainly a divide in terms of conclusions about science, but I don't think there needs to be a divide in terms of, like concern for each other, in terms of just our common humanity and the fact that, we can all be friends. Because, look, I agree 100% with virtually none of my friends. I can't think of any of them that I would agree with completely. And the fact that you and I disagree about rocks, that's okay. That's fine.
And I think that it's fair for both of us to admit we would like to be able to present our reasons for believing and hopefully influence the other person. But if we do not, if I present my argument to you and you present your argument to me and neither one of us is compelled, then we would, I believe, both of us would be able to just let go. We're not going to shove it down our throat.
Yeah, no, I agree. And in fact, one of the things I said to Chesh when I popped in here before the show was my goal is less to convince you or anyone else. Well, not anyone else, but like my goal is less to convince you about the correctness of my position and more to get you to know what the scientific position on these topics are, so that when you try to argue against them, you at least are arguing against the actual position. Because one of the things that I noticed in the video that you did was that very frequently what you presented as the presumable mainstream explanation wasn't actually what the mainstream explanation was. So, for instance, many times you talked about strata forming a year per stratum. That is not the explanation. Or you said that, or you very heavily implied that the mainstream explanation for the wave was that it was lithified first and then folded, which is also not the case. So my real goal...
Wait, you have to
at least
last sentence?
Oh, sorry. So another thing you seem to think is that the mainstream explanation for the wave in the Navajo sandstone that we spent a lot of time on was that it was already hardened rock before it folded, but that isn't the mainstream explanation. So one of my goals here is to say, look, if you want to argue against mainstream geology, right, the geology that essentially everyone is doing with the exception of a half a dozen guys, then what you really have to do is you have to argue against the positions of actual geology. And in many cases, you weren't. And so one of my goals is less to convince you and more to say, here's how to do a better job arguing against this by doing less of an accidental straw man. Because I don't think you're intentionally straw manning what the science says, but because you got the conventional explanation wrong in almost every case, that becomes a problem because it means that you're critiquing an idea that no one is proposing. So one of my big goals, Cindy, is really just like, hey, I would like you to understand what it is that the science says, so that way, when you do critique it, you do it better.
Well, actually, the argument is a huge issue because I keep seeing that. Okay, the layers is a good example. You said that one layer doesn't represent 1 year, 1 year. But you did state layer is a seasonal variation. And so even if it's not a year, it's still a time increment.
Yes, well,
a large time, not a small time.
That's actually another thing that I point out in the video is that different layers of different kinds have to be assessed individually in order to get an idea as to how long they took to form. Because there are seasonal laminae, but there are also areas where sedimentation doesn't vary over the course of a year significantly, and so you don't get seasonal laminae. There are areas where you do get rapid deposition, like when you showed images of Isla Espiritu Santo in Mexico, in the Gulf of California. Most of those layers probably were formed in less than a day because most of them are volcanic from things like tuff or basalt, both of which tend to be deposited very quickly in a very short period of time. So that's one of the things where a stratum, by definition, like it's like just logically a requirement that it must take some time to get there, right? Because things don't just pop into existence instantaneously. But how long each one takes is something that has to be assessed on a case-by-case basis by looking at what is it made of, what are the physical characteristics, what is the surrounding environment like, do we see fossils? If so, what kind? So you can also do things like you might have a lacustrine deposit that doesn't have. Right. Well, so what this does then is if you can determine
signs of no age.
Right. So, so what would be a sign of no age? What would that look like?
When you see that the layers are so flat, you could put a piece of paper in between them, and there's no sign of time. There's no sign of growth.
Flat contacts don't indicate low amounts of time. So there's a number of things with flat contacts. So flat contacts can actually be the result of erosion of the top layers, especially in the case of an unconformity, like we saw with the wave, right, where the unconformity had the various layers of the wave flattened out, and then more strata was put on top of that. That requires time for that erosion to happen. But also, in a relatively flat deposition environment, which generally speaking, deposition tends to be very horizontal. If there's no deposition for a time because the depositional environment changes such that there is no deposition, even without erosion, the next layer will be relatively flat. In fact, in some cases, extremely flat. And the reason for this is sort of like if you're building like a parfait, right? It doesn't matter how long you take between the layers of the parfait. The next layer that you go put on top is going to conform to the shape of the layer below it because they're flowing one on top of the other.
Tell me if I'm wrong. The existence of layers at all indicates time.
Each layer has to take some amount of time to deposit.
Right, and time is going to be relative, so long and short can mean almost anything depending on whatever context we're talking about, right? So long can be a couple of seconds. If you're planking and you've never planked before, you're going to plank for a minute and it's going to feel like a month. Right?
Well, I think basically worse be within 150 days, or can it be within a short time, or does it have to mean millions of years?
So it's going to depend on the individual strata in question, right? So like I said, when you had the island Espiritu Santo, right, that whole thing probably could have happened in less than a year, right? Because at the bottom, it's primarily some breccia made of mostly basaltic fragments that can form very quickly. And then on top of that, there's some tuff that can also form very quickly. That entire bit of rock probably could have happened in less than a year. So like, okay, that's fine. But then you get to things like, Sicker Point in Scotland, or the cliffs of Dover, or the coral mountains, literal mountains made of just coral in Texas. And no, that for those to form in a year is essentially impossible. I mean, you would have to come up with radical new biology and physics in all of those cases to explain those in the course of the year.
And I guess that's the general that I used. And I think that everything had to form within a year, but I do think that everything can be explained in the time frame of the Bible and not millions. Even if we don't know how.
You're welcome to think or believe or posit whatever you would like, and then try to have those conversations. That's totally fine. I mean, that's what this whole channel is predicated on. The whole channel is predicated on being able to have these kinds of conversations, though in some cases they may be more or less difficult depending on, like, how comfortable you are. If it's too hot out, like where Dapper is right now, and his face is melting, or
it is melting a little bit.
If you drank too much that day, you're hungover, right? Or so like all of these things are going to be relative. I think Dapper's main point is that you're going to have a hard time arguing what you're arguing and arguing it well in a way that's going to be convincing to people if you're arguing a slightly different or slightly off point from the point that's being made. So you can say, hey, listen, I believe there was a global flood. Here's why I believe that there's a global flood. And you say, this is wrong, this is wrong, this is wrong in geology, but this, and this are not what geology say. Then your premise is going to fall apart right out the gate, right?
And actually, I would like to present my arguments based on shutting down mainstream. I would like to present my arguments based on, okay, this is what is reality, this is what I'm looking at, and this is what it looks like. Instead of having to, I don't want to have a bunch of straw. I need a bunch of straw.
Yeah, if you do you want to do that right now? Would you like to make your whole point right now, or is that what you mean, or just in general?
That's what I was doing in the video, and Timmy was feeling like I was doing straw man, and I don't recall that, but
not intentional.
He's probably right. He's probably right. I want
to be clear. I don't think you were intentionally making a straw man. I think you were misinformed about what the consensus. Okay. As long because this was not an accusation of impropriety.
Nobody ever assumes the worst of Cindi because Cindi is the sweetheartest, bestest person ever.
True. That's true. If you assume the worst about Cindi, that's fighting words.
Yeah, that is fighting words. I'll fight you. I'll do it right now.
What I intended to do was just look at the formation and say what it looked like. I didn't mean to misstate. I'll have through it to me.
All right. Well, I think at this point we're more or less
watched on a regular basis was always, okay, this is what you say evolution is. This is what the textbook says the evolution is. And now you're saying this is not what evolution is. And this is what a larva is. And this is not what a larva is. And so I think sometimes that needs to be the beginning of the conversation. Let's define our terms here.
Yeah, that's fair.
All right, so, guys, we're 2 hours and 45 minutes into this. Let's define our terms.
Yeah, well, so look, I think at this point we're probably at a little bit of like an impasse where I think there's a whole lot of research where I think that needs to be done, right? Like, for instance, I think I need to send a few more videos to Cindi. I think that perhaps I should gather some more examples of why it is that I find the level of scholarship in young Earth creationist geology to be not just lacking, but dishonest. So maybe I should find some more examples there of why this is such a problem for me. And so I think one of the things that we did make progress on is that I do think that I am now more cognizant that you are less likely to simply accept either of the two major flood models as something that you're going to believe automatically. I think I had been previously going under the assumption that you would probably be assuming one of those is the likely model that you're going to go with, but that seems not to be less the case. And I think that now I've explained why it is that I think that you are not adequately explaining the mainstream position in order to criticize it. And I think that both of us coming to that better understanding is a positive result. And perhaps it's time to go look into some of those things and say, hey, what else do I need to know?
We have made progress. Everybody feels like we've made progress. I'm going to call this successful as far as I'm concerned because my bar is set really, really, really low. To be clear for anybody...
See, there's a
go ahead.
There's a conflict, okay? Because on the one hand, I want to be sensitive to science. On the other hand, I don't want this to go into a PhD. I want it to. I don't.
You want to be able to understand it on a layman's level. You want to be able to look at this and say, I understand what I'm looking at. I want science to be able to explain to me what it is I'm looking at in comprehensible terms that feel like they're common sense.
That don't require a PhD.
Right. I shouldn't need a dictionary to understand why the Earth is not flat.
Right.
I think that's reasonable. I don't think that's a big ask.
Don't make an analogy between the flat Earth.
Why not?
Because I'm not flat Earth.
I don't think you are.
Are we going
to? Okay, I'm just going to say though.
Sorry.
Watching a certain guy who runs a little compound down in Alabama try to defend the globe Earth against the flat Earth was hilarious because he had zero arguments.
Oh boy. It's very interesting to see when like two people who utilize bad arguments collide on things that they disagree with. So like there's something special when somebody says like, well, I agree with this and I disagree with this, but these people are using the same argumentation that they're using to say why they agree with this, and it's just like watching two trains just.
I saw a flat Earth versus geocentrist fight once. That was weird.
Oh no, flat Earth versus geocentrist. The Earth is flat versus the Earth is the center of the universe. Oh boy. Okay. Oh God.
And like the flat Earth is like, oh, NASA's a liar. But so. Yeah, it's.
That's amazing.
Luckily, that's not happening now.
No, that's not what this channel is about. Although I'm sure it will happen at some point.
Wait, hold on, Kaylin. You're not a geocentrist, are you?
No, I was going to ask for everybody.
Okay.
what everybody's time is, because it's later here.
We're wrapping up. Geocentrism is the belief that the Earth, or the theory, or the posit that the Earth is the center of the universe and the sun goes around the Earth.
As opposed to heliocentrism, but I think there's a connection between flat Earth. Doesn't flat Earth believe the opposite?
Yeah, flat Earthers are also geocentrists, but usually if you just say geocentrist, you're assuming a globe that is the center of the universe.
And yeah, I don't know. I don't know. The sun is too loud. The moon is made of cheese, and I don't care anymore. All right, we did have like one or two things from the chat. We'll get those out. We're gonna bing bang boom those out real quick, and then we'll get on out of here. So Rodent No Last Name said, a question for Cindi: what in geology would disprove the biblical flood model to you?
You broke up there, Chesh.
Oh, sorry. Rodent had asked question for Cindi, and the same question to Dapper as well. What in geology would disprove the biblical flood model to you, and vice versa for Dapper?
Okay. Maybe a lack of sedimentary layers all over the planet.
For me, what would demonstrate the flood as a global flood that's going to wipe out all life would be all I would really need to see is a globally correlated turbidite deposit that contains the kinds of remains I would expect from a global flood, which means that they would have to be largely unsorted by taxonomy or environment, rather being more or less hydrologically sorted. That would do it.
Can you say that again?
A globally correlatable turbidite deposit containing remains that are sorted not taxonomically or by environment, but rather hydrologically.
I'm sorry, one more time.
A globally correlatable, so that means it can be found in lots of places around the world, and we can tell that it's going to be roughly the same time in the history of the Earth. Turbidite deposit. Turbidites are the kinds of rocks deposited by things like floods and tsunamis and high energy events like that. And I would expect the fossils in it to not be arranged in terms of things like what groups of organisms they belong to, like we tend to find in the fossil record as it is, or by environment, which is another way we tend to find animals. Rather, I would expect them to be sorted primarily hydrologically, rather than either by environment they lived in or by their classifications.
I think that, for example, a bunch of mammoths wouldn't be found together, or a bunch of, what was the other one, taxonomically
sorted.
So I would expect things like elephants, as well as things like Allosaurus and moss chops, to be sorted into a single layer. Another example, it doesn't have to be those three exactly, and have them be sorted instead of by where they lived or what kind of animal they are, instead be sorted by how fast they would sink underwater.
So in other words, if they all lived together, the flood would be so high energy that they would be basically blended.
They would just have to, they don't have to live together as in locally,
Right.
They would just need to live at the same time.
Right. In fact, I would expect animals that didn't live together to be mixed together, because that is what happens in floods, where like if a flood comes, because floods start in the mountains and they come down, and the headwaters bring organisms from that entire range all the way together. So I would expect to see a combination of organisms from different environments all in the same layer.
Wait. I don't think the biblical flood started at the mountains. It would have started from the fountains of the Great Deep, which are under the ocean, and it would have been a rising ocean level.
Sure.
Okay,
I think that was just an example.
Sure, if that.
If water is rushing up the continent, there's still going to be a headwater that's going to go from the coast towards the mountains. So it's still going to result in organisms that are not sorted by environments, no matter which way it rushes. Because the fact is, it's high energy headwaters that are going to be primarily picking up organisms.
So you're saying instead of a rapid flood mud flow that would bury everything right where it was, you would require that it would be.
Yes, because floods transport things long distances. mean, that's just what they do.
Unless it's buried by mud.
Are we suggesting a global flood that was also global mud?
I think the two can't be separated.
Mud flood confirmed.
You would have some areas that could be mud for sure, but we're talking about globally.
Well, I think if you have a planet full of water, you're going to have a planet full of mud.
I feel like we're moving goalposts here.
Yeah, why don't we just go on to the next one? Because, I mean, look, we could
just what would
spend all day.
Dapper, right?
I'm just fascinated that you would even concede that there was something that would convince you. I think that's cool, so I'm looking for a hole in there.
Oh, yeah.
Go ahead.
I love it. I'm all about how eager Cindi is. Okay, Stupid Horror Energy for 10 had said, in Oklahoma we see dinosaurs where it's obvious they were dead and out in dry environments for a while. The degradation of the ligaments, etc. Does this show that the flood wasn't the culprit? So, meaning that the flood did not necessarily kill all these dinosaurs.
As opposed to rapid burial. I would think that there's enough different environments in the flood at different times of the flood that there might be some laying around, but I don't really know.
Wait, so are you saying that the flood didn't kill all the dinosaurs?
No. I'm saying that if the flood killed animals, that doesn't mean that they were laying around. He's saying that there was time for degradation, so they had to be laying around rather than buried.
Well, they're saying that they were dead in dry environments.
Right, rather than burial. But I think in general, we see things that are not degraded and rapidly buried. I'm not even aware of those. That'd be cool to see.
Well, you have to check out Oklahoma. Next one is Throw the Dwarf for 5 said, Dapper, you don't need to bounty hunt. I will give you more money. See new Star Wars show to get the joke. So I guess people got to watch the next Star Wars stuff. They're not sponsored.
Well, you know what? Throw the Dwarf. I'll just say this. That money went to Chesh, not me. You'll have to super chat on my streams.
Hey. Rose asked from Tim, said, is it possible, Cindi, that the translations of the Bible have had a mistake? Is it God breathed, but humans are imperfect and have an agenda? So she's asking about do you believe that the Bible is perfect, or do you believe that human error and translation has gotten mixed in there so the Bible isn't necessarily inerrant?
I think some versions of the Bible have a lot more human influence than the others. And this was a big question for me when I was first saved. I mean, this is just some human man telling me what to do. And if Jesus is God, then what good would it do for God to just appear to one generation? Wouldn't he need to preserve that message for the future generations if he's only going to come to the planet? And if he's able to raise from the dead, he's certainly able to preserve his word. And I do think he did in the King James.
So you believe the King James Bible, version of the Bible is inerrant then? It's been maintained by God.
I do. Somehow. Okay. Primarily, yeah. At least primarily. The message, the fundamental message of salvation has to remain available, or else it's less gesture.
Well, I think there might be a difference between the fundamental message of a story and whether or not the story remains 100% accurate.
Yeah, how much error can you tolerate?
Right, well, yeah, so I think that's their question. They're asking, like, are there any errors, or are you saying that, fundamentally this is the best version we have and the fundamentals of that, although there may be errors within?
I haven't found any errors that have rocked my world. And I believe if the Lord has a message for humanity, what good does it do? Only for one generation, and it's corrupt after that. I think he's going to make an offer of salvation. He has to make the offer clear. He can't change the offer every time a human.
I've altered the deal. Pray I do not alter it further. All right. So it sounds like that you believe that there are errors, but they're inconsequential.
I think that there's a possibility. I think actually, doesn't the King James say that the Leviathan is a hippopotamus or something?
Yeah, that's one of the questions that comes up later about whether or not you believe that there might have been unicorns before the flood, or do you interpret the passage as the rhino or another creature?
Can I add a
I've heard that
on my own?
Mm-hmm.
Oh, sorry. I just want to say that well, the textual history of all of the books of the Bible is long and complex. I do think that at this point, scholars have a pretty good handle on the likely original reading for virtually all passages. In the cases where that's not the case, the difference is usually fairly insubstantial to the overall meaning of that section of it. So I will say that I do think that what the Bible actually says is not something that there's a whole lot of debate over in terms of what the actual text is supposed to be. In virtually every case, it's pretty well established that it's either one particular reading or a small number of competing but still very similar readings. So I would say that if the question is just, are the texts that we now use to say this is what the Bible is, how likely are they to represent accurately the originals that were written? I think that in almost every case, they're very likely to represent those originals quite well.
I think that you know that that's not the question, though. The question is about the inerrancy, not necessarily of the translation itself, but the information within.
Look, I'm not a biblical inerrantist. I think most people...
They weren't asking you.
Well, yeah, but I just wanted to pop in.
I don't believe
So what you're saying, Cash, is that there's a difference between an act translation from the original and inerrancy, and I don't really understand.
I can write down I can fly, and somebody could accurately translate that for years and years and years and years. It doesn't mean it was true or accurate.
And I think that's actually what Timmy would be saying by definition, because he's
saying that
he believes
the translation,
but that he doesn't necessarily believe it.
Well, I mean, that's up to
that's what you were saying.
I don't know what he believes. That's not what his channel is about. He doesn't talk about whether or not he believes the Bible.
I won't tell you whether or not I believe the Bible. I will, however, tell you that I'm not a biblical inerrantist.
There you go.
Okay, so you're drawing a distinction between translation, what does it say, and if it's true or not. And like, I can fly.
Right. So for instance, there are things that the Bible says happened that I am very confident did not happen. However, I am also very confident that the text that we have now is very substantially the same as it was composed. So the original authors, what they wrote is very, very similar to what we have now. In some cases, it's going to be identical.
All right. That was the majority of the questions. I don't think I missed any. Does anybody have any? I do want to thank all of our guests for coming. Thank you, thank you, thank you. Very greatly appreciated. You guys make the show what it is. Don't forget to like and subscribe and share and join the Patreon and become a member and get cool emotes or whatever. We have conversations like these in the Discord all the time, so feel free to join us in there if you become a member or a Patreon. Do you guys have anything that you're selling or anything that you guys want everybody to know, or where you're at or how you feel, or any last words?
No, I'm actually happy.
I want to hear Caitlin because she's been.
Yeah, no, I said I was actually happy to have participated in this. This was my first, I guess, live debate. So this was an experience. You guys have been great for making my first experience an enjoyable one.
They don't roast.
I would blush, but dinosaurs can't do that.
See, that's why I need to see your face.
You gotta make a better dinosaur.
You are seeing my face. That's my face. It's right there.
Oh my
I'm gonna make some art where I'm gonna take Dapper's avatar. I'm gonna add little anime blushies to it.
Nice.
Cindi, you have anything for
You're
us?
the creator, Dapper. You can make it blush.
Dinosaurs can't blush, so I can't. Look, I'm not the creator of this. That this was my parents who laid and incubated the egg.
God made Dapper unable to blush, and that's sad.
How do you know this? Chameleons turn pink and green and orange.
Dinosaurs aren't chameleons.
Yeah. Your story is on your page, right? Dapper.
Sorry,
yeah, Caitlin, I'm going to send Cindi the links to the whole leaving Earth creation, and she can forward that.
Okay.
All right. Anybody got anything they want to pitch?
Deconstruct your faith. I'm going to come and kick your butt.
Come hang out tomorrow on my channel at noon Pacific, 3 p.m. Eastern. I'm going to be talking about. We should be trying to finish up another Andrew Snelling lecture. Because we all know how much I absolutely love Andrew Snelling and how he's my favoritist geologist of all the world. So that's going to be probably a couple hours. Then on Tuesday, I'm going to be having my birthday stream. I'm going to do a Kent with Ben, but Maddie from Science Side Up is going to be there. So that should be fun. Wednesday is my Power Rangers tabletop RPG actual play on my off-topic channel. Thursday is going to be a video about whether or not dragons and humans or dragons are real. And this goes well beyond what you might think of as the
Are you using my position that dragons are bugs?
No.
I'm throwing this out.
I don't take it.
Dragons are bugs.
Right. Yeah.
No, they're not.
And that's as far as ahead. That's about as far ahead as I want to go.
All right, you can also join me with Mania for Dumb Feck Friday, but it's Saturday because this was today. So I will see you guys also tomorrow. Again, don't forget to like and subscribe. Special thanks to Stupid Horror Energy for not only super chatting, but also becoming a member. So enjoy your new emotes. I look forward to seeing you in the Discord if you decide to join us there. Thank you, everyone else who super chatted. And I am about ready to take us out. Is there anything else?
Stick around, Caitlin. I'll turn on my...
All right,
I'll turn on my webcam after we're on there.
All right, I will. You guys can stay in the call. I'll make sure you guys are all muted. You won't be able to hear each other. You guys can stay in this call. It's totally fine, no problem. Silver said, thanks for the stream. Have a good night. And last thing is, hey, listen, just because the science says something different than young Earth creationism has nothing to do with whether or not your faith is accurate, has nothing to do with whether or not God exists. The science is just the science, and those things... You know what? Sometimes you can find a way to have them coincide, and you can justify them. So, you know what? Just because geology says one thing does not mean God is real. And that's kind of stuff this whole channel is predicated on. So, we're going to get out of here, and we'll see you guys next time. Bye.
Bye.
Good to see you. Happy birthday, Jimmy.